Hey there, and welcome to my second video in the series of Python for Maya artists. The first video was an intro course, and that was for newcomers to the Python language, and we went over things like objects and the syntax of Python, and learned to write functions and how to get them integrated into Maya and write some basic tools. And we also looked at the commands module for running Python commands in Maya. And in this video, we're going to take the approach, a more intermediate approach. We're going to assume that you've got a fundamental knowledge of Python to a certain degree, to a basic working degree. And we're going to get into a focus on class structures and inheritance, which I think are key concepts when you're writing larger, complete tools in Maya and you want to reuse code and redistribute code. And we're also going to look at the user interface, how to write some user interface code, and a little bit of the Maya Python plugin API, which is the lower level interface into Maya. So like I said, this video will start off with a general Python lesson, and then we'll get into more Maya specific things. And I would say that the beginning of this video is beginner to intermediate, and then most of the video is intermediate level, and then we finish out starting to borderline on an advanced topic when we get into the API. I also wanted to explain that whereas you might see these examples being focused on maybe more pipeline and general topics, my background is a lot of pipeline development, and you may be an animator or do rigging or do shaders, lighting, whatever it is. And while I can't cover every single example for every facet of 3D, you can take all these concepts and use them to write things that are specific to your needs. Alright, so let's get started looking at class structure and inheritance. Okay, so let's start by asking, what is a class? A class is a structure that's similar in how it looks to a function, but encompasses functions and attributes and definitions that make up a common description of something. Whereas if you had these objects like this, and this is a sphere and a cube, but they both are geometry. And in Maya, they have translation, rotation, scale, visibility. Both of them have this functionality. And then beyond that, they split off into their specific functionality. A sphere has a radius, whereas a cube doesn't. It just works in terms of height and width and depth. So you can define common functionality in a central abstract area like geometry, and then split off and just inherit everything that you defined up here and add on things that are different, or override things from the original one that are now a different way of doing it. So a class lets us put this code together and reuse it and write things that we can keep building off of, and it helps us keep our code very organized. And let's, in order to illustrate that, I'm going to pop open the script editor, bring this up a bit, and clear this out here, and I'm going to be working in terms of pasting code. I typed a lot more in the first video, but there's a lot more code in this video, so I'm going to paste in blocks of it and we'll go through it line by line and figure it out. In the project directory that comes with this video, I have all the code, even in stages that we're working on. We're going to look at sphere, and I've got two stages of it where we start simple and then we add on some more. So we're going to look at sphere 1, so you can open that if you want to follow along, and I'm going to paste in. Okay, this is a basic start of a class. We're calling our class sphere, and just like we would define a function, the way we start a class is saying the keyword class, the name of our class, and then in parentheses you would put in anything that you want to inherit from a parent superclass. A superclass is a class above our current class that we inherit from, and a subclass would be the class that's doing the inheriting. This is the old way of saying to start a new class, but the new way in Python is to always inherit from the lowest level object, which is object, and we put it in parentheses. So if we're starting a brand new class, not inheriting from anything, we at least want to inherit from object to get some of the new class functionality. And then everything we define is in the class block. Now, the first important thing that you'd want to know about in a class is a special function called init. And you can know it's special because it has double underscores surrounding it, meaning it's a built-in that we're going to overload. An overload meaning that object came with an init, and we are going to define our own init. And what we say is when any new sphere gets created, it will always automatically run this init function for us and set up our new copy of a sphere. And we can put in the attributes right here. So we want to say our sphere has a default name value called sphere and a default color value that's just an empty string. And what you'll notice is this keyword self, which is new to the concept of classes coming from functions. You didn't see this first attribute called self. But in a class, when you have, because you're defining a template, whenever you have copies of your sphere, you never know what that object is going to be by the end user, but you know that inside your functions we can say it's called self. So every copy at that moment is called self, and every function in here should start with self in these methods. So what we do is when we bring in name, we need to save it. So we're going to say self.color equals the color attribute, and self.name equals the name attribute that was passed in. Now it's saved. And if we were to run this, and I'm going to have two tabs open, one where I keep this code, and then I'll switch over here, and I can say s equals sphere, and if I print s, you'll see that you get a sphere object. That's different than if I just ran the sphere class. It's telling you that you're looking at a class sphere, but when I made a new instance of it, it says now it's a sphere object at this point in memory. So we've got this, and if I do a dir, if I do a dir on this, you'll see that it comes along with these built-in attributes that come with the class, and at the end is our two properties that we defined. So I can say s.color, and that was a default nothing, but s.name is sphere. And I can change that by saying new name, and I can also change the color by saying color equals red. And now if I print this, you'll see that we set it to red. So this is how you can create objects that carry their own properties, and you can pass these around. You can have 1,000 of these in a list with different names, different colors, and you can loop over them and just check the name of each one, the color of each one. And you can set this up for any kind of object you're creating that you want to add your own properties to. So that's the init, and then you would have more functions to do specific things with a sphere. So I'm going to go into our sphere 2, which adds a little more functionality, and I'm going to paste this in. Now, this is just tacking on some more functionality, and I'll explain what each of these things do. We've still got the init. I set the default color to red so that it always starts with a color. And you'll see up here that there is this definition of a tuple with some default colors in it, and it's outside all these functions. Now when you put something right here, this is called a class attribute, and it sets it up only once, whereas if you were to put it in here, if you were to put colors down on a line like this, self.colors, every time you create a copy it's going to redefine this. But we're going to say that these are the allowed colors that this sphere can be, and they're never going to change. So we're going to put it up here once as a master constant for all the objects. And what we did here is we added two setter methods to our sphere. The first one sets the color, the second one sets the name. And the reason you could create a setter as opposed to just the way we assigned it directly is now you have some control of how the color gets set. So we take the color and we make sure if the color is in self.colors, then set the color. Otherwise, do nothing. So it prevents them from saying an orange sphere or a yellow sphere. And when you create this colors, every instance has that reference to color. And when we come down here into set name, we make sure that they pass a name, and we also make sure that it casts the name into a string, so that even if they pass some other crazy value, we always make sure that the name is being set to a string. So let's set that in there. Let's create a new sphere, and let's look at what our color is. We didn't set a color, but it's red. We could have instantiated it with color equals blue. And now it's a blue sphere. Now, you can still do this method because there's nothing protecting you from it, but we've added this functionality, set color, which is the preferred way to set a color. And if I set the color orange, you'll notice that the color is still blue because it's not in s.colors. It needs to be in there. Now, if we change that and we added orange into this definition, then it would allow these colors to be set. So these setters give us a way to protect and do sort of setup before we set those values. We'll get into some more talks about the attributes versus the setters in some later examples. But the idea now is that when you had this sphere class and you had it in this file, like we said, sphere1, you can now reuse this code, this class. You can import this class, and you can build off of new shapes. And we're going to look at this. This is sort of a generic example of a class. It has nothing to do with Maya for the time being, but we're going to change this class up and see how we can make this a Maya sphere that sort of wraps around the commands Python module. So that'll be next. That's in Maya sphere. In the Maya sphere directory, we've got a couple files, and let's start with this Maya geom. And I'm going to bring up just an editor so we can take a look at a bigger view. But here's Maya geom, and it defines a class called Maya geom. We set an init with a default name called geometry, and we just make sure that the name variable gets set. And then we know that when we are defining a piece of Maya geometry, we can rename it, any piece of geometry, with the commands rename command. So we're just going to set a setName command that can set the name of the geometry and then update itself. And this is so that we can wrap the concept of a piece of geometry into a more Pythonic object that we can work with. And then we also define getTranslation, which we know that if we use commands transform command and pass it the name of the object, we can query the translation attributes. So we're going to wrap that up as a getTranslation. And again, we don't know what the object will be. We're just passing self because we know self will be that object at that moment. We also define a setTranslation method, which takes a default x, y, and z attribute, and we say if x is not none, then move it in x in the object space. If y is not none, move it in y. If z is not none, move it in z. So this sets up a framework for a Maya geometry object. And then what we're going to do, and you can't do much with that right now because it doesn't really represent any specific geometry. But if we create in Maya sphere 1, we first off import from the Maya geom module the class name Maya geom, because the module name is Maya geom, the class name is capital. We import it. Now we have this class. And you remember I said that in here is where, in this class definition, is where you define who you want to inherit from. So instead of object, we're going to inherit from Maya geom. That means that this Maya sphere is a subclass of Maya geom, and Maya geom is the superclass of Maya sphere. So we have an inheritance setting up. And whenever we inherit from another class, we want to make sure we define our init if we need it. But if we do define an init, we should always make sure to call the superclass init, because it might have its own special setup. And if you overload this method and you don't call this, you might lose out on some basic setup. In this case, it wouldn't hurt us because we're setting self.name here, and we also set self.name here. But if this had special other setup that we don't do, we want to make sure that we call it first, and we pass the reference self in to the init, because init requires at least a self attribute. And if it had other attributes, we could pass the name in down here as well. And then in addition to that, we're going to make a sphere. So anytime you create a new Maya sphere, we're going to make a sphere with these default attributes, and we're going to take the name and set it to self.name. So let's take a look at how that works. I'm going to hide this, and I'm going to go in here, and for a second let me talk about some quick setup. What we have over in this tab is something that makes it really easy to work in Maya when you're working with classes and you keep changing the code. What I have is this import sys, and then I add to the sys path the location of the Maya sphere code. So it puts it onto your Python path. Now normally you would actually edit, in the last video I talked about how to edit your Python path so you could have all your code in an area. You would just put your code in that area, but in this case I'm working with a kind of a foreign path. So you can also do this just for working with the project. Just add this path to your Python path. Now you have all the code in here available to you. And first thing we're going to do is import. Now you don't need to do this. I'm going to start with this right here. Import Maya sphere. Now we have Maya sphere. Let's jump over here, clear out our previous stuff, and let's say msphere equals Maya. Now if you remember, this is the class, and or the module, and inside the class is the Maya sphere. So we need to say Maya sphere 1 Maya sphere, and we're going to just do the defaults. Now watch what happens. Let me hide this here, and let's see here, move this over. Okay, I have my scroll set up very strange. I don't know why. Okay, if we create this sphere, it actually makes a sphere because we set up our code. Let's see here. Because we set up our code, anytime you init a new sphere, it's going to make the sphere, and it's going to save the name of that sphere. So if we do msphere name, you have the actual name of the sphere, which, if you look over here, is the actual name of the sphere. And we had msphere get translation, if I can even say it properly. Right? Now we can also do set translation. And set translation, if we look at our code again, you'll notice that in the Maya sphere we don't have any of that. So where is it coming from? It's being inherited from our Maya geometry class because we set up some basic functionality, and it just comes along when we inherit from it. So our set translation takes the optional XYZ values. So let's go back over to Maya, and let's say we want to move it in X. X equals 2. Notice the sphere moved. And you'll see up here in translate X, it also moved. We can say 1. It moves it back. I can add the Y. Let's move it up 3 in Y. And you'll see what we did here is we wrapped up the concept of a sphere, which is normally just a string, because when we reference with the Python commands module, we know that any object is always just going to have the string path to that, but we wanted to wrap it up in something that's more Pythonic, so we don't have to keep calling commands.transform commands. It knows its name. We know we just want to set the translation or get the translation, and you can see when we get it, it's actually getting the translation based on the name, because under the hood it's running the functions that we wrapped up. Now let's expand the class even more. Let's open up Maya sphere 2. And in Maya sphere 2, what we have is a little bit more in the init. What we have is we passed in this thing called keyword args, and we set keyword args name, object equals true, and we call that sphere. Now, why did we do this? What we did here, this could be called anything we want, but in habit I just call it KW args, means keyword args, and it represents the idea of doing key equals value, key or value equals key, like that. Instead of having to explicitly say this is what our class takes, I can use this special Python symbol dot dot. That means expand this into keyword args. So whatever they pass in, name equals value, it comes in like a dictionary. As you can see, I treat it like a dictionary. I say make sure the name is equal to the name, make sure the object is set to true, and then when I call sphere with keyword args, which then expands into all the options, it ends up calling sphere with whatever arbitrary stuff we pass to it. So how does that work? Let's go over here. And this is why I was setting it up this way. I can say 2, right? And then I can go over here and let's delete this and set this to 2. Now, this is where we would use that idea of keyword args. We can say name equals sphere 2, and this in here is where we would pass any of our functions to the command sphere reference. And let's see, I can look this up here. Let's see, quick help. You'll see that all of these, I don't have to code all these into my class. I just have to accept any arbitrary keyword arg. So if I want to say specify the radius, let me create a new scene here. If I want to specify the radius equals 5, you'll notice that I don't have that radius function in my code, but I passed it on to create the sphere, and now the sphere radius is 5. So that's a way to pass along when you're wrapping up these functions with this KW args. The version of this called args, like this, would be everything that doesn't have a value as a list. This would come in as a list. So if I had gone over here and I said 1, 2, 3, not equals anything else, those would just come in a big list that I could use. But now we've got this sphere that's got the radius at 5. And let's look at our code again. And the reason we did it like this is because we wanted to make sure it was always running this flag as true. That's a way for me to make sure that this is always true. And then we just save the name as normal. So as you can see, we're still inheriting from geom. We just modified our init a little bit, and then we expanded this set translation. Now, the previous one didn't have set translation. The base class Maya geom has this set, but this is somewhat, messy, inefficient. It's repetitive. So what I did was I said, well, I want to make this implementation of set translation better. So what I did was I just looped over all the attributes x, y, z, and I used this special locals command, and that tells you all the variables that are available in this scope inside set translation. So this locals would show you a dictionary, and it would have XYZ available to it. So I'm looping over XYZ like this, and then I'm pulling out the value of XYZ, and I say if it's not none, so if they passed X is not none, or Y is not none, or Z is not none, this will be true. And I create a basic dictionary of options where I say the name, which in this case could be X, so X could be true, or Y could be true, or Z could be true, and I make sure that object space is true and absolute is true. So these are our options for the move command. And then I just pass these options in using our special double star. And all this does is take a dictionary and expand it into keyword arguments. So this move command will get arbitrarily called depending on is it X or Y or Z. So I just overloaded this. Now, when you call set translation, it'll work the same. It just runs the code a different way. So if I were to be typing in here, and I made a change like this, and made some changes in my code, and I went over here. This is why I have these reload commands. This is how I kind of like to work sometimes. I made a change, so I had this. Now if I tried to use this, it would still be the same code because it's still in memory. So what I need to do is reload it, and you can tell it worked right because this will say PY. If I read it again, notice the PYC. Every time you it imports it, it makes this optimized version. So you can tell if it picked up your changes because the next time you ran it, it said PY. That's where the changes happen, but now it's still the same. So if I went over here and I made a new sphere, it would pick up the new changes. Let me clear this out here and get rid of this quick help. Okay, so I'm going to pull up the code again, and feel free to pause if you need to take a look at this code here. This is really not specifically necessary. There's nothing wrong with this, except it's good to try to not repeat your code, because the benefit of me having switched it to this more dynamic version is if I added another variable like weight or whatever the attribute was, I wouldn't have to go and copy paste that same block of code again, because this will just pick it up. It's going to loop over every locals that got defined, and if the name is not none, then it's going to add it to this list. So it was just a way to optimize and show you the concept of overloading, where it will pick up this newest version because of the way that the class resolves. It will first look at itself. So my sphere is first going to look at everything that's defined here. If it doesn't find it, it's going to go looking at Maya geom for it. All right, so let's open up the third version. And all we're doing is just adding more and more functionality. This is all the same. The set translation is the same, but then now we added get rotation, set rotation, which is very similar, except now it's calling commands rotate instead of commands move, and scale, which is calling transform and scale. They're very similar, but now we have three things we can apply. So if we go back over to Maya, go over here. I have a fast wheelie mouse that's set right now. I'll probably fix that in the next cut, but bear with me on that. So now we import our third sphere. And let's say our third sphere, we'll give it a name 3. That comes in, and you remember that we can actually now msphere, msphere set scale. And scale, looking at our code, has optional x, y, and z. So I can say, let's just scale it on the x to y 2.1, and let's squish it down to 0.5 on z. Now watch the sphere and your channel editor, and you'll notice that this wraps up the concept of scaling. And now we can say m sphere get scale, and you get back the actual scale of the object. And we have those three functionalities now. Now the sphere carries a lot more functionality, and if we were to keep coding and add some more changes, I can just reload and make a new one. Now as you notice, every time we run this, we get a new copy See? Now, we're not doing anything to handle that, and the problem is that you only have one sphere object, sphere 5, and these are just sort of dead in the water because our code is not doing anything to handle it or clean it up. There are ways that you could sort of watch that, but the idea here is that you're wrapping up the functionality of setting up these spheres. So let's go back and look at some more of our code. So let's open up this Sphere 4. Now this one's going to have a lot of description in it for your benefit to look at later with lots and lots of comment. I'm really trying to put as much comment in here as possible so that you can review this in your own time and retain all this information that that I've set up. But let's take a look at this line by line here. These are just docstring comments. They attach themselves to the stuff you put it under. And this init is still the same. Now here's something that I've added that is not necessarily something you would do in, say, production, but it's a way to show you. I was talking about how the spheres don't clean themselves up, right? So every class has another built-in, like this, called del. And this is for what happens when that object is deleted. Whereas this init is what happens when this new object is set up. This gives us a chance to clean up. So we can override our del method, and we can say self.delete. Well, what is self.delete? Let's scroll down. I defined a method called delete that first says self.exists. If it exists, run the commands to delete itself using its name. And I wrote another method here called exists, which checks if it exists. So you can see I've wrapped up multiple commands module things. Commands object exists, commands delete, and I just wrap that all up into here. And you can see here's the examples of how you can delete. Now let's take a look at what happens here. We've got our new scene. Let's import our new sphere. And let's call it, we'll just do the defaults. Let it name itself 4. Okay, so we've got a sphere. Now the way you can delete, if I have x equals 1, and if I delete x, meaning tell Python to clean up that variable, x no longer exists. Now we can do the same thing with our sphere. Notice that the sphere disappeared when the variable disappeared because we attached the cleanup of the geometry to the cleanup of the variable. Now I'm not recommending you necessarily do this in your production environment. It's more of an example of class functionality. I can make this again, and a better way to do that would be to just call the delete method, because this gives you more control of when you want it to delete. Let's try a little example. Let's try something where we do for I in range 10, and let's say create a sphere and msphere dot set translation x equals I, let's say I divided by 2. Okay, and let's save them too. Let's say spheres equals list spheres dot append m sphere. Okay, let's run this. Oh, let's see, what did I mess up here? So what this is telling us is because the name is default and we're trying to use the same name every time. So let's just say name equals sphere I, so that we make sure each one gets a new name every time, right? So now we've got these spheres that all got made, and they're all part of this list. As you can see, we've got this list of our Maya spheres, right? So if I delete the spheres list, I'm not deleting geometry. If I delete the list, they all go away except for this one that I've selected because it was still in memory. It was the last one that that got created. Sorry here. Yeah, it's the last one that got created. So all the other ones got overwritten, but it's the last one that exists. So if I now delete M sphere, see, this variable is still alive because we did a for loop and we kept overriding sphere, and when the loop finished, sphere still exists. So then we delete that, it goes away too. And so that's just an example of the delete method. I document here that it's not really what you do. You'd want to use this delete method. So let's keep moving down here, and some other things that I overrode. This str method is another built-in. This says what happens with this object when you cast it to a string. If any time you want to treat it like a string, what happens? So let's find out. We have this here. If I say M sphere, we get this Python type printout of what you're looking at. But what if I cast it to a string? Sphere. Now, what's cool about this? Let's take a look. That we're returning the name of the node. So what's great about this is if, say, you were going to pass this into other functions that took, like commands dot, if you were actually doing a commands dot move, or a get attribute or whatever, I can just take the string value of this, and now I've got something that the commands module expects. It turns it from a Python object into a string. So it helps you keep integrating it with the Python modules. And you could say, you could decide, however, as long as you return a string, you can define how to turn it into a string. Now, let's take a look at this method here. And this requires a little more explanation. Up here in the init, something we changed, and let's look at an example from this one. In the init right here, we explicitly create our sphere. But in our fourth version, we want to kind of generalize this a bit more. We want to just call a create method with the arguments that came in as a dictionary, and we're not expanding this, we're just passing it a straight dictionary in this case. And you'll notice that this has an underscore in front of it. That means a protected variable or function or method, meaning that it's not meant to be called by anyone using this class, like say in Maya, like we were using these, you wouldn't call create. It's meant to be used internally. And it's a way to separate functionality when someone's looking at your code. They kind of know that's not meant to be called by you. It's meant to be implemented. And all it does is we just moved the same code down into this create method. And what's nice about that, you'll see towards the bottom, I'll show you. But let's keep moving on here a little bit. We didn't really change anything else except, well, you'll notice that I also have this do transform, which is a protected method. And let's compare it to our previous one here. Look at the repetition of code. And you'll notice this is almost identical to this and this. And all we changed is move, rotate, scale. So instead, look how much simpler this looks. Set translation just calls do transform with the command that it should run and the XYZ, because these attributes don't change. So what this protected method does is it takes the function that should be called and an expected x, y, z attributes, and it takes that exact same code that we had, and the only difference is this line here. When you pass in that function, command scale, it comes in as the function, and then we call it like a function with the value from before, and self.name is the name of the object, and then all the options that we just made. And you can see that you can pass commands around. Like if I do commands.move, you'll see that this is a built-in move method of the module commands. I haven't called it yet. I just have the reference to the function, and you can pass this around just like any other object, which is really cool in Python, that that functions can be just passed around as first-class citizens like that. And so they are also objects. And so I can pass a function in, and it becomes known as function here locally, and I just call that. So you can see it really cleans up the code to just call these do transforms. And now here's where you see some more inheritance. What we were making here, move this over and get the attribute editor. What we're making is a NURB because we didn't specify. That's the default for the sphere command. Let's move this out here like this. Now, what we did is, well, we've defined this whole great structure for creating a sphere. It happens to be a NURB sphere by default. But now let's say we want to make a polysphere. And we want to make a polysphere, and all we have to do is subclass myosphere, which is up here at the top. Make sure we call our init, but we're going to change the default name to polysphere. That's all we're changing here. And then we're going to define a new create method, which instead of calling sphere, calls polysphere. So let's go ahead and try that out. And that's the only difference, but we get all the same functionality along with it. So if I get this down here, actually I'll put it right here, and we'll call this p sphere, and we'll change this to poly. You'll notice that now a polysphere came in. It's a completely different type of geometry in Maya, yet we can treat it the same way. I can still say set the scale. I can get the scale. I can get the name. And it works exactly the same because we just passed the functionality down. And you can see how this can be really great when you get into writing large tools. You get into writing large tools and you build up these libraries of common code, and it kind of teaches you how to segment your code into general stuff. And then we started with Maya geometry, writing base class things, and we progressively added more to a Maya sphere. And then once we had this Maya sphere, we decided we want a new type, and we didn't have to duplicate any code. This could be in a separate file. This could be even a separate developer, user, artist, who is just pulling in from another file and just changing a couple things because they want some specific functionality. So this is called overloading. And we saw how we can, when we develop and we make changes to the code, we can just hit reload. And a key thing to remember is when you import, make sure you import the actual module and not saying, from this module import Maya sphere, because you won't be able to reload that way. Just import the whole module, and it makes it a lot easier just to say reload, and then you can see that it picked up your changes right here. And that pretty much does it for the basic idea of class and inheritance, and hope you picked up something from that. And next what we're going to do is we're going to move on to some more complete scripts that have a lot more functionality, a lot more definition to them. In this section, we're going to look at a larger project. And what we're going to do is we're going to create our own asset importer tool. Now, regardless of Maya having support for some assets, and this is somewhat of a general tool, and I think it really will help to outline a larger structured piece of code. And what it'll also help us do is get into some UI stuff. And I have a lot of documentation in it, and let's just start taking a look at what we have. So in the asset importer directory, we're going to start with this series of code right here. And we're going to start with asset importer 1. and I will show you what we have set up. Now, before we open the code, I've also included this area here called Asset Library. And in this Asset Library, what we want to do is have a file system location. It could be anywhere, but we'll keep it here for the project location. And under that, we want to support the concept of either shows or categories, whatever you want to call them, but we'll call them shows in this term, the general show, the war show. And we want to have a structure where in each one of these shows we have assets and then various images for the assets, like this, right? And we want to be able to bring in more assets to our tool, and that's why I have this new assets area here, and these are just some raw assets that we might want to import with their pictures. So we want a tool that can bring these in and let us import them into our scene and give us a view. Now, it won't be 100% complete in every area, but we're going to do enough of it to where you can see what we're getting at. So let's start with Asset Importer 1. I'm going to bring up my code here. And Asset Importer 1. Now I have a lot of documentation in here, but let's go through this bit by bit and see what it does, right? So we've got our Asset Importer class, and that's going to be our basic structure. And we're going to define a couple constants. And again, go ahead and pause anytime you need to take a look at the notes that I have here. But a couple constants we're going to start off with is we're going to say, okay, we need to know generally where our asset location is. And the asset location being where is our asset library root directory, so that you could relocate it anywhere. So we have this class level constant, and then we have where is the default image. If an image is not provided, where would the default come from? And then we want to say what's our default show if an asset doesn't have a show. We're going to call it general. You can change that. And then we're going to, I'll get into these in a moment. But now you see that I have these assigned to some more variables, and I'm doing that up here only for the purpose of this project to make it easier on you, because you may not have all your Python paths set up and whatnot, and I want it to be pretty straightforward and work for you. So what I did was I created some some file level constants. These are constants that are for the entire module that anything could access, any class could access. So I'm saying that our project root is going to be, and this is a special way to say, this will tell me the path of the current file we're in. So that's Asset Importer 1. We're going to use the OS module to get the directory name. So that's the directory of the file. That would put us here. And then we're going to join that together with two directories up. So that would take us from here to here, right? And that's the project root. And then what we want to do is we want to say, okay, the asset root is that directory plus the asset library. So it joins it. So that puts us here. So that's an easy way just to get a relative path, so you don't have to set up Python paths, and I don't want to confuse you. You see down here, you would normally uncomment this, and you could set a full path to your asset library. You don't have to use my special version. And I do the same thing down here. You could uncomment this, a full path to the, let's go ahead and put that like that, full path to your default image, but in my case, I just want to use my relative version. And then down here, what we're going to do is these are going to be some names when we start tagging what's been imported, and these will create some attributes for us on the imported assets. So we're going to get down here, and when we initialize our asset importer, we want to know what the show is, what the root directory of the asset is, which will be the asset location for now, and then we're going to call this set asset root. And what set asset root does, let's see here. Actually, I don't have that set up yet. Let's go ahead and remove that. That's from step 2. Okay, this is just a basic overview of what we're setting up so far. So we've got our init. And when you start laying out these large projects, it's nice to actually just type out the functions you're going to do, and that's pretty much what this is. We need something that can add an asset into the location. We need a way to list assets by show if we want to. And we want a way to load assets into Maya, given a name of an asset or a show. And then down here what I have is another class that we're just going to call asset, and this is just our container for how to define an asset. And we're going to say an asset has a name, an asset has a scene file, an image file, and a show. And with this asset file, then we could import it, load it, view it. So this is the general structure of what we want to start with. And let's look at number 2, step 2. Okay, so now what we're doing is we're going to take that structure and start filling in some of the blanks. Let's see what this structure looks like. So in addition to the add, list, and load, we've added some other stuff, and let's go top to bottom and see what we're doing here. Let's go up to the top here. Okay, so all of this is the same, and now what we're doing is I added another flag for verbose in case we want to print more information as we're doing things. And what I did was I said, let's set the default show to either the show they pass in, or if it's blank, to the default show. And this is a way to do an either-or assignment in Python, I think 2.6 and newer. So what this will do is this will say, okay, if they didn't pass in show, then pull the show from right here. That's how we set our defaults with the constant. And then we do this set asset root. And what I did with set asset root, when I jump down here, is it sets the root level of our asset library. And it's just a fancy way of setting this root directory. But what it's going to do is it's going to make sure it exists. If it doesn't exist, it's going to use os make dirs to make all the directories needed leading up to this root directory. So it's just a fancy way. If we go up to the top, had you just set this, it could exist, it could not exist, but it's a nice way to make sure that that it does exist before you get working on it. And so let's move down. And this is a new concept that I wanted to show you called properties. And what properties are, they're exactly like the way you would use these attributes just by setting self.equals verbose self.verbose equals self.root equals show. But what these do is these are computed properties, meaning that we can actually control how they get set. So I've got one right here that's show dir. And what it does is it returns the root directory plus the current show. So it's a quick, easy way to call show dir. And the way I would use that is if I just said, self.show dir. That's it. That's how I would get it back. But the neat thing about properties is if I tried to assign to this, it would not work, because you can say that this is only readable. Right now, this is only a readable property. And this is just a little symbol that says that it's a decorator that says that this function is a property. Here's another property, self.show. Now, why did I do this? You saw in the last class example, I just had my variables just straight accessible. But why did I do it like this? Show is actually a hidden attribute, and what we're going to do is we're not going to let them actually access show directly. We just want to make sure that, okay, they can get the show, sure, but if you try to set the show, we want to make sure that it matches a pattern. And I'm using a regular expression right here, and I'm just going to make sure that the show matches the patterns any lowercase letter, any uppercase letter, a dot, an underscore, or a slash. So that could be just no spaces, no funny symbols, just the basic characters to make a show. And it would raise an error if it was not a proper show format. So what this does is, and you can see the syntax here is, this is to make the getter, and these pop-ups are very annoying, aren't they? This is to make the getter, and down here is how you make the setter. So you have def show, and then you have def show again, but you say that this one is actually the setter, and you can take the variable in. So the way you would use this is like this. You would say self.show to get the show, or self.show equals new show, but instead of it working straight on the attribute, it's going to do the computed property. And this brings us to another concept. I know we've got a lot of concepts here. We've got the properties. You've seen regular expression right here, and you can do lots of pattern matching with it. And this is an exception that we're raising. Now this is not a built-in exception. We've actually created an exception down here called importer exception. It doesn't do anything. It inherits from the built-in exception, and what it lets us do is just catch exceptions that are internal to our program, so we can tell the difference between other errors and ones that we generate ourselves. So you don't have to do anything necessarily. You could make more advanced exception classes, but all I'm doing is inheriting from our importer exception. Let me go back up here again. So if the show doesn't match this pattern, then raise our exception, which we could catch if we wanted to. Otherwise, set the show. All right, so let's go down here and see how we filled in the add asset. So add takes an asset and uses that to import it into the system. So let's see what the first things we do here. We're going to perform some basic checks. We're going to use this isInstance to make sure that the asset they passed in is actually an asset class, because we have our asset class down here. If it's not, raise a type error and say it's not the right type. Then we're going to move down here and we're going to look at the asset, and we're going to say asset.scene. If not asset scene or not is file scene. So what this does is this says if they didn't set the scene, or if they did set the scene and it's not a file, that's another exception. And let's take a look at what we've done with our asset down here at the bottom before we go any further. Asset is inheriting from a standard Python dictionary, because we're just going to use a basic dictionary but add some extra checks on top of it. So we can do that. We can extend a dictionary and subclass that and use it the way we want. So we create our init, we make sure to initialize the original dictionary, and then we want to say that there's some default keys. Name, show, scene, image. We say for each of those, set the key to nothing. So no matter what, a fresh asset will have those empty keys. We set, this is a representation which we looked at, actually we looked at str earlier. This is another version. And what this does is this is how an item is printed. Not when you pass it to a string, but when you just print it back on the screen. This is what the object will look like. And we use this to nicely format all of our items. And this is another way. There's a lot of stuff packed into this, isn't there? There's another way you can do string formatting. You see how I've instead of doing %s, I've put these variable names inside of these parentheses, and at the end you can give it a dictionary. And because self is a dictionary, we are inheriting from a dictionary, it will look up all these keys. So that's a really nice way to format strings. It's going to look up all of these and fill in the blanks, and that's how we'll get our representation. And then we go down here and we've got some more properties. We set the getter on how to get the name. The name gets the key, or if it doesn't have the key, it returns nothing. This is the setter. It doesn't do anything fancy except set it as a dictionary. Same with the show, same with the scene. None of this does anything really fancy. It's just a way to nicely set it up. So let's jump back up to our add function. So now that we are we know that we've got a valid scene file. We're that far. Now let's start pulling out the information. So we want the show is either the asset show, or if it's not set, let's get the current show. And then let's also get the current show directory. Now, what is that function? That's a private function we made, or a protected function, because that's for our internal use. So we're going to jump down here into get show dir, and this returns the show directory, kind of similar to showdir property, but it also checks if it exists. If not, it makes it. So if it doesn't exist by joining, and what it does is you can give it a show. So if they gave it a show, we're going to join it with the current root directory and show. Otherwise, return the showdir. And then, so the idea here is we want it to, if we're referring to a show, we want it to make this directory if it doesn't exist. That's what we're getting at here. So if it doesn't exist, make it. If it couldn't make it, if this fails, this is how we catch errors. You wrap whatever code you want in a try except, and you say, if this fails, and if you were to try this, it will fail with an OS error. So we know we can look for the OS error, and anything else would be a different type of error. So you say try to make the directory. If it exceptions with an OS error, and it'll pass along the exception. We call our commands.error from the Python module for Maya to fail out and tell us it failed with trying to make this directory, and here was the error. Why? Maybe it's a permissions error. Maybe it's something on your file system you can't make it. So if that works, we keep going, and we need to make the images directory, and that's going to be the show directory plus the images. So it's going to make this directory right here. Let's go back over here. And it does the same thing. It tries to make it. If it can't make it, it's going to fail out. And finally, it's just going to return the show directory that it made. So let's jump back up to here. So that's how we get back up to here. We call this get showdir with the show of the asset to make sure the asset exists or the show exists, and we get D. So moving on, we're going to get our naming for the new file, and what we want to do is we want to name the file when it's imported the same as the scene name. So we're going to get the base name of asset scene, and that basically rips off the directory and just gives us back the file name. So that's the file name of the scene, and then we split it into the name and extension, and then we say, okay, the name is either the asset name, and if the asset name, so they can specify the name if they want in the asset. If the asset name is not set, then it will just use the scene name. You see how it's asset name or name. Then we go down here and we format the name back with the extension, and we join that back with the show directory. So we've now built a new destination file path that would look like this. So it will basically give us the path to this here. And we do the same thing with the image. We either take the image name, the image if they've given it to us, or the default image if they haven't specified an image. We rip out the extension by doing get the file name, split the extension, and then take the last item in the list, which is the extension. Then we join it back together with the new path. So we get we join it with the name, and then we join it with the path. So we end up with this right here. And the last thing we want to do is we just want to check if the asset already exists in the library. We're just going to fail out for now. You could do other things with it, but we're just going to say you can't import the same asset. So down here I'm using the shutil module, which has some extra functionality for copying files. So we're just going to say, okay, copy the asset into the destination, copy the image into the image directory, and then update the asset that was passed in with the new location. So if they set up the asset for the source location, it's now going to come back as the new asset location, and then we print the asset. Let's see how that actually works. Okay, so we're going to pull up this right here, and we're going to set up our path. Okay, let's make sure we set it to asset importer. Oops, let's make sure we run the whole code. And let's get rid of this here. And let's say import asset. We'll do from, because we're not going to keep reloading everything. Let's take a look here. So what we're going to do is we're going to say asset importer 2 will import the asset importer. Actually, we will just import the whole thing. So let's just say asset importer 2. Okay? All right, so now that we've got that in, we've got the ability to make an asset. See? So let's make an asset. Let's say asset equals asset. And let's say the asset name, now let's take a look at what we want to add. Okay, let's go into our new assets location, and let's say we want to bring the chair into the scene. So let's go back over to Maya, and to make this a lot easier, let's just change our current directory. I'm going to import OS, like that, and I'm going to say os.changedir, and we'll just change our directory so that we're right here, and we don't have to keep typing out full paths. You can do the same thing, whatever's local to you. So now, when I type out, we know we want the chair. So let's do the name, and if we didn't set this, it would call it chair. But let's say, let's call it new chair asset dot scene equals, and we can do a relative path. So we can say it's new assets chair, new assets chair.mb, asset.image. Now if we didn't put an image, it would use our default PNG, but we do have an image. So let's just grab this and put that here and change it to PNG. And for the show, again, we could not set a show, it would go into the general show, but let's set a show, and let's call it the furniture show. Did I spell furniture right? Maybe. That's okay, we're not learning spelling right now. So we've got this, let's set all that, and what happens when we print our asset? Now see how nicely this prints? This says the name, the show, the scene, and the image, and this is all where our asset currently resides. And it prints that way because if we bring up our code and we go down to asset, we set the representation to print this way. So whenever it tries to get the representation of that file or this asset, you'll see this nice printout. And it's great when you have a list, as you'll see in just a minute. But so we printed that out. Now that we have it, we have our asset importer. Let's create the actual importer. We'll just call it I. Let's call it something short. Asset importer, and then that's the module, so we need importer. And as far as creating a new asset importer, we can give it a default show, and we can also be more verbose. Let's just not give it anything. Let's do everything default. So we've got a new asset importer. Now, in order to add that, let's check our code again. Let's check how we add something. All we have to do is give it the asset, and it will find out where to put it based on whether you set the show or not, or whether you have a default show. So if we say I add asset, and I want to pull up, let's see if we can see what's going to happen here. So we have our asset library, we have our two shows. Let's see if I can make some room. Like that. Okay. And let's see what's going to happen here. So if I add it, as you can see, it created our furniture show. I'm still skeptical of whether I spelled furniture right, but you can forgive me, I'm sure. And it brought over new chair asset and put the image in the image directory. And there's our chair. Right? And what did it give us back? If we look at what this asset is, you can see that it modified the path. Now we're using relative things, so I mean this is still valid, it's just slightly bigger than it would need to be, but it definitely points at where the new asset is, where the new image is, the show. So now we have this valid asset. And what we can look at next, let's go back and look at our code, and we have this list function. And the list function can tell us all the assets that are in a given show. And the way we've set this up is it can take a name, it can take part of a name. See, specifying a name returns only assets whose name contains the pattern. And whether you want it to search all shows or just the current show. And the way we set the current show, if you remember, is just with the property. So let's go back to our list. Let's look at some of the code here. And it basically checks if we're looking at all shows, then it does a listing of the root directory and gets all the shows under it, builds up full paths of all the shows, and puts them in the directory list. So then we'll have a path to each one of these shows for it to look through. If you're not doing all shows, then just get the directory of the current show, and we'll put it in this list. Then we're going to loop over every directory that we want to look at, get the show name, get everything that's in that show name. We're going to ignore any hidden files that start with a period. We'll just continue. Join that item name with the full directory. We make sure that it's a file because we don't want to work on subdirectories. And if it is, we're going to split off the extension and get the name of the file. This is where we check if they set a name pattern up here. Then we say if name is set and the name is not in the item, continue, because we only want to match patterns, and that only happens if the name is set. And then we find the image. We get the name of the asset, and we attach it to the extension of the original image, and we build up a new asset object. You see we set the path, the name, the show, we join the image, and we add it to our asset list, and we return it. So let's see what happens in here. If I say i.list, and I'm not going to give it anything. Let's clear this up. I'm not going to give it any arguments. It's printing everything in the general show. We have 3 items in our general show. We got the palette, the ladder, the magnifying glass, and where they lead to. Now, that's because our current show is set to general. What if I say all shows? Now we've got every show. We've got the general show. We've got 2 items in the war. Or actually 3 items in the war. Is that 4 items? How many items we got in the war? And let's see. Here's our furniture, right? Let me clear this. Now, what if we just want to find everything that starts with mag? We know that we've got assets in there, and they start with mag. We're going to search all shows. We're going to say name equals mag, and it's going to say if that matches anywhere in the name. And if we had 5 different things, a magnum gun, that kind of stuff, we would get all those assets. So we have a way to search for our assets. And if I said false on all shows, we get general. And we can change our show by saying show equals war. Now what if we did this again? We get nothing because it's now checking the war show, and there's nothing in the war show that matches. So now we have this way to add, we have this way to list. What other functionality do we have? Well, we need a way to get those assets into Maya. So we have this other function called load, which takes an asset object or a string name, because since we are able to search by name, we might as well allow it to load by name as well. So you can either give it an asset name or you can give it an object. And the way we figure that out is we say if it's an instance of an asset, then the asset is the asset we gave it. If it's not, then list it first and get our assets. And then we have this print function, and this is just a little helper. Let's go down here. All we did was wrap this up. If we're in verbose mode, print, and that's just a flag from the init right here. So if you set this to verbose, you're going to get a lot more printing, and that's just a nice way so you can on one line do verbose printing. So what we do is we clear the selection list in the scene. For each asset in the assets that we're going to load, uh, what we're going to do, and this is kind of an interesting way to find out what's been loaded off the scene, and it's the only reason we're doing this is just to show more examples of what you can do with the code. But what we do first, we do an ls, and we try to find all assemblies, that being the top level node of any hierarchies that come in from our file. So we want to get the list of all of them in the scene before, and then we import our file, and I'm going to import it as a reference, and we set the namespace to be the asset name so that we don't get namespace clashes, and they come in with the asset name. And then we get the assembly list afterwards. And you notice I'm wrapping these in a set, and a set is a Python object that is like a list and a tuple, but it can only have unique items, and you can do some special stuff with set, so you can only have one of each kind of item in a set. So after that, I take my after set, and I get the difference of the before set, and this gives me back everything that's different between the two, so I can see basically what assemblies just came in without having to worry about what the file command gives me back. I can just check the difference in the scene. So we say for every item in the new stuff that we get back, we're going to add attributes. And you remember earlier I showed you the attribute asset name, attribute show. Those were up here. You can see in the class level attributes. And we set these to asset name, asset show. Let's go back to load here. So what we're going to do is we're going to add attributes, string attributes, and we're going to set them to the name of the asset name and the name of the show. That way we're tagging our assets, and we could look them up later. And then we just print some more, and we select everything that was just imported. And so let's find out how that works. All right, so we've got this asset right here, this chair. Let's import it. So we do i.load, and it could take a string or the asset name. Let's just pass it our asset object. I'm going to clear this list. And by the way, I'm just going to show you, we could turn verbose mode on, equals true, just if we want to see more printing. Okay, let's see what happens when we load this item. All right, so it went in, it found the item. I'm going to close this for a second. We've got our chair, right? And what did and you see it made the namespace the name of the asset. And if we look at the extra attributes on this top level node, we created an asset name, an asset show. We set it to the name and the show, and we could look this up again later since we have our listing. So we could end up finding every asset that's currently in the scene. And we might do that in a couple more steps here. Let's look at one more bit of code here. Now in the asset importer 3, we added one more thing. Let's close this up so we can see it. We added this function called find imported, because now that the last thing we did was we tagged our assets, it would be great to find them in the scene if we just loaded this up. If you handed me a scene that had assets in it and I had the asset importer, I could just use this method to find out what assets are in this scene. And what we do is it doesn't take any arguments. It returns a list of, it's a tuple. Each item in the list is first the string node name in the scene, and second the asset object that points to it on the file system. So first thing we do is we list all the transforms in the scene, because that's what we tagged, only transforms. This could be widely extended by anyone else later on, but for our purposes, we're just tagging the top level transform of the assembly. So we get the all the transforms in the scene, and then for every transform, we query the asset attribute name that we set. We see, does it exist on this node? If it doesn't exist, it's not one of our assets, so we continue. But if it does have our asset attribute, then we grab the name and we grab the show off the node. We set our show in our asset importer so that we're currently working on that current show. And we list that name that we just got to get the actual asset object. If it got an asset object, then we're going to grab the first one because our list command returns a list, so we're going to grab the first one off the list. Otherwise, we didn't find an asset for it. And then we append the node name and the value we got for the asset, and we return it. And let's see what we get over here. Let's go down here, find imported, and all we have in the scene is the chair. Oh, look at that. No attribute find imported. That's because we're using asset importer 3 or 2. We need 3. So let's go over to our import. Now it's imported. Let's change this up to 3. Now we've got version 3 of asset importer. We'll just keep our verbose as true. And now we should have this function. And look what we get back. It found at this path, this is the node name of the asset in the scene, and it gave us back the asset object. And this is going to be really useful in our next part where we talk about wrapping a UI around this, because while it's great to get this functionality, you don't want to sit here and be typing all of this. It would be really great if we could actually wrap this up into a UI. So in this chapter of the video, I want to start talking about user interfaces and how we're going to start wrapping them around our code. And the first example we're going to look at is how to do it in the Maya UI using the built-in commands, the same way that this UI has been built up. And then we're going to show you some alternate ways using Qt, and eventually with PyQt, which is a little bit more of an advanced install, but I still want to show you the option. And I also want to address how I've been going about the code so far. I know it's been a lot of information, but I just want to show you a lot of examples that you can pause at any time and really just focus on. So I figured it's best to give you more information and let you take advantage of this being a digital video. All right, so let's pull up some code here. And what I want to look at first is we have this asset importer win. And what we've got is a new class called asset importer win. And what we're going to do is import our asset importer module that does all the work, and we're going to wrap a UI around its functionality. And I'm going to explain everything along the way here. Now what I did was the way I'm referencing this, I set up code being the root, and then asset importer is a package, and you can tell it's a package because I've got the init file in here, which means that this should be treated like a package. So I can say from asset importer dot asset importer 3 import everything in there. And right now we're using asset importer 3. 4 will come at a step later. But what I do is, so we import the asset importer, and I'll explain this import in a second. We start our init with just some basic setup. We want to create an instance of our asset importer and save it as the importer attribute so that we can access it repeatedly. And I want to set some defaults, like a default window size, a default size for the icon, a default name for our window in Maya so that we can find it, and some other things that we're going to need, and I will describe that in a second. But next thing I like to do is create a show function, and this is different than the term show in the asset importer. This is actually like visually show, and this is where I like to put the code that actually builds the window and brings it into view. So we go into this show command, and the first thing it does is it calls this self.close. And what self.close is, let's jump down to that. That just says that it looks at the window and the default window name that we have, and it queries if it exists. If it does exist, it deletes it. So we're just going to simply say, if it's already visible, clear it, and let's just show a new one, just to be safe. You don't have to do it that way. You could show the existing window, but for our purposes, we'll just clear out the window. The next thing we do is we always start with a window command, and this creates a new window with the preferred name. The name could change, so what we do is we create the window and then save it into this variable so we can keep it. But this is the name we desire, and we set a title. The window is allowed to be resizable. It should not be retained when it's closed, meaning that if you close the window, it doesn't hide, it actually deletes. You could actually say true, and when you hide the window or close it, it's actually still there. You can show it again. And we set our default window size from up here. So we want a 1000 by 600 window. So then that creates our window, and we get the name of it in that window variable. These pop-ups are really killing me, aren't they? Okay, and then what we do next is we're going to create a layout. Now, working with the My UI can be a lot of trial and error, and if you look at the commands for the form, and let's actually do that. Let's pull up our script editor here. I'm going to create a new tab, Python. Let's get some help and show the quick help, and let's say form layout. And actually, we should go to the documentation. Let's see if I can actually pull that up. Oop, it's big, isn't it? Let's now, if I go to the form layout, and we're in the Mel version, we actually want the Python version. Okay, now form layout can be very confusing. It's got a lot of options of how you can lay out everything, but what you can look at the bottom, if we scroll to the bottom here, you get these examples, and this is a really good way to find out what stuff does, is to just look at the layout examples. These are all runnable commands here. If I actually just take this and jump over here and paste it and run it, you get the form layout, and you can see how you can lay out one control and then controls that align with other controls or to the layout, and you can see how they are set to resize depending on how you actually attach them. So it's a real good way to play with the UI. It's a lot of trial and error I've found. So I'm going to move this off here, keep it for when we need it again. And let's hide this help. Now let's go back into here and look at the code. So we create a form layout, and we save the variable. And whenever you make a layout, you're now in the context of that layout. So any child items you make are going to be assumed to be a child of the previous layout. So now we make this button, and we're going to have, we want a button that can reload the library. Actually, I should probably just show you what this looks like, and then we can go over the context of the code. So let's change, I'm going to change my path. I'm just going to add this path from the code level, and I'm going to say import asset importer win, and what we want is the asset importer window. So let's say win equals asset importer win. To create that, win.show. Alright, we got a pretty big window here. Oh good, it fits right in there. Alright, so this is what we're going for. Right, we've got our title, asset importer, we've got this button that says refresh library on this side of the screen, and we've got the refresh imported on this side of the screen. So what we want in this list, in this view, is to get all of our assets so that we can actually import them. And in this list, we want to see everything that's been imported. And if I hit this now, it's pulling up all our assets. Right? It's pulling them off of the asset location that we set earlier because we imported all these files already. And if I hit this refresh imported, currently we don't have anything in our scene. I might as well just show you how all this works, and then we'll get into the code. So let's see if I can make this small enough for you to see. I'll make this even smaller. And I kind of find some of the My UI stuff a little limiting. Let me see if I can bring this over more. Okay, so let's say you got your asset importer open, You've refreshed your library. These are all the latest assets. And I say I need a chair. So I click that. I got a chair. Right? And I can bring this over here. I say I need a barrel. Bring a barrel in. And then I can say, I need an axe. So that just brings these all into the scene. We're using references, so they're coming in, they're tagged, and I can hit this button right here, and it looks up in the scene, and it knows the nodes that were imported. So if I had 1,000 items in here, I could still find my assets. I could click on this, and you see it's actually selecting the assets in the scene. It's changing the selection. So now we understand what we're going for. Let's actually go back into the code and take a look. All right, so now you understand what this reload library button is. And I'm going to try to turn off these pop-ups. Hang on one second here. Thanks for bearing with me. That was kind of annoying, wasn't it? Okay, that's all fixed. All right, so we've got our reload library button. And we create the button with the label. And then we create a scroll layout. Now, we were in the form level. This button becomes a child, and then when we create this scroll layout, we're now inside the scroll layout. And inside that scroll layout, we're going to create a grid layout. And the reason we're doing that, let's go back over here, and I'll just leave the window up so we can keep referencing it. But the reason we want this is, notice that if this window gets too small for the amount of, if we had many more assets, we want the scroll field to come up. So the way we want this layered is we want this area to be a scroll layout with a grid layout inside of it. So let's bring back up our code. And we've got that. We've got the scroll layout. We put a grid layout inside, and then we say we want the cell width and height to be equal to our default icon size, which we set right here. We want 128 size icons, and we're just going to pad them a little bit. So we take the size of the icon and just add a little padding, and then we say we want 4 columns. And then what we do here is we set the parent back up to the form, because as we created these, like I said, we jumped down into children, and now that we're done making our grid layout, we're going to leave this empty because the items are going to populate automatically when we hit the button. So we're done with this grid layout for the time being. We're going to jump back up to the form, and now under the form we're going to make a new button because now we're doing the other half of the screen. We create this row layout, and we didn't really need to do this, but I was going to add more buttons, but I didn't. So now we add this button which goes in the row layout, and if I had added a couple more buttons, they would show up in a row along with the button. So then we create this refresh imported, and we jump back up to the form, and we create a scroll list. So if we look over here, we have the button with a row layout where if I added more buttons, they'd show up along this row. And then we jump back up to the form level, and we added this text list. Let's go back in here. So there's the text scroll list. And the last part, which is the most complicated part to understand when you're doing Maya UI, is actually setting up the form layout. Now we added everything to the form layout. It's all here, but it's not laid out properly. And what happens if I were to comment this out, right? And we go back over here. Let me close this down. And our trusty reload. And create a new window and show. It's all wackadoo, and that's because everything just got lumped in under the form layout, but nothing's been told where to go. So that brings us to this next part, the form layout. And what you do is you say the form that we made, we're going to edit it, and first we're going to do an attach form, and this means that we want to attach the following items to the form itself by edges. So we say we want the button's top to be attached, or the button to be attached to the top of the form with a 5-pixel offset. We want the same button to be attached to the left with a 5-pixel offset. Let's bring this up so I can keep talking about it. Right? Okay, so we want, again, see the 5 pixel offset, 5 pixel offset. We're basically saying tuck this into the corner of the form. Move this over a little bit here. Okay. And then we say, okay, we want the scroll to be tucked to the left and 5 from the bottom. So you can see it's against the left and 5 from the bottom. And then we want our import button to be against the right and against the top. And you can see it's against the right and the top. And this is actually the row. So the row goes all the way to the edge, even though it's invisible right here. So it's 5 and 5. And then we want our list to be against the 5 on the right side and against the bottom. And you can see here it is 5, 5. And then attach control. What this does is takes one control and attaches its edge to another control. So once you lay out some things against the form, you can lay out, so what we say is the scroll, we want the top lined up against the reload button. And you can see we want the top lined up against the reload button with a 5 pixel offset. Same with the imported buttons, which is a row. We want the left aligned to the scroll. And what this does is when you resize, this stays attached. So this is locked to the right of the form. This is locked to the left here against this widget. These are locked together. So once we resize, they stay locked. Let's pull this over here. And lastly, we want the list to be locked to the left and to be locked to the top part to be locked to the import button. So this is locked to, actually the first one we locked here, and now we're locking this here and to the top of the import button. So you can see how we're locking those up. And then the last part here is where we set up our commands. Well, second to last part, there's some more here. What we do is, and a lot of people just leave the commands for the last part. So you already have your buttons, we're just going to edit it. And we use the command to set, now what this does is, this is the command when the button is clicked. It's going to call another Python function that we write lower down. So we say, when this is clicked, call this function. And we don't have this at the end because we don't want to call it now. We just want to pass the reference. In Mel, you would do something like this, where you'd be passing a string. But we don't need, and you can do that here as well. But the problem with that is it's going to call in the Python space. So if you wanted this to call like a commands function, you know, like another, that's fine. But we want to reference internally, so this self won't really have any meaning if we do it in a string, which it's also nicer to do it this way anyway. So this is an actual reference to our function. And so the same with the imported button. We want it to go to this refresh imported. And then here's something interesting. When you click on items in the list, the select command calls a function as well, so that it'll actually select the asset in the scene. And then lastly, we just want to save our widgets so that in the functions down here that get called, we have a reference. So we have the name of the window that got made just now. It's the updated name of the window no matter what it's called. We save the name of the library right here to asset grid, and then we save the name of the imported list right here to the imported list variable. Now we have these saved and we can show the window. And that's where you get to this point. Now what happens when I click this? When I click this button, this fires, and let's look at what refresh asset. Alright, refresh assets. Now let me start off by showing you why do I have this random args in here. And if you remember me saying earlier, what this star does is it basically makes a list. Args is like that when it comes in. So this can get as many arguments. It could be coming in as 1, 2, 3. They'll all come in as a list in args. And the reason I'm doing it like this is kind of a catch-all, because when Maya fires its buttons, it likes to pass these arbitrary values. Not arbitrary, I mean you can read what they are, but it passes these values in. Like if you had a checkbox right here, and I click the checkbox, it would pass in a true or false of whether the checkbox was activated or not. So we don't really care what the button passes, so we just kind of grab it and just never use it. But you got to have that because you'll notice you'll make a mistake. I'm sure I've done it too, where you'll define your function like that, and you'll get an error saying there's not enough or there's too many arguments being provided. So you just catch it like that. Now what we do first is, because we know the name of our grid from earlier, we saved it, we query the grid layout and get all the children currently in the grid layout. We get all these children, and the reason we're doing this is we need to first clear it before we refresh it. So we get the children. If there are any children in it, go one by one through the children and delete. This is the command to delete UI elements. So when and this is exactly what's going to happen, I have these in here. When I hit refresh, it's so fast you can't even see it, but they all delete and re-add. So if I had added another asset or someone else had added another asset, I would just hit this and a new asset would pop into place. So now that everything's clear, we want to add the rest of the add the new assets. So this right here, I'll explain this in a second, but we're going to go, and you remember we saved our importer when we initialized up here. We created an importer, and it carries with us. So we're down here, and we say, you remember this from the last example from the commands. We have our list command, and we're going to list all the shows, and we're going to loop over every asset that comes back in that list, and we're going to create an icon text button, which is exactly what you see here. An icon text button is a button that has this extra text below. And we're going to say that the parent is the asset grid. The style is, as you see, vertical with an icon and text. Width, now this should actually be, and it's good that we're looking at this, this should actually not be hard-coded like that. This should use the icon size. So let's actually fix that. Let's say self.icon size 0, because that's the width and that's the height. Great. So now we're more dynamic. We're actually using the right icon size. We can change it up top and it'll propagate through wherever we're using it. We set the image to be the asset image, and then we set the label to be a string formatted text where it's the name, and then on the next line it's the show. And the command for when the button is clicked is this thing called command. So let's jump up here for a second, and there's this function called partial, and it's really cool. This is called a callback, and it's something that when an action happens, it calls back a function that we gave it. And what we can do with partial is it lets us wrap up another function with an argument to be used later on. So if we go to the top of our script, that's what this is from functools. Functools is function tools package or module, and we import this partial. Let's jump back down here, and what we do is we want to attach a different command to each one of these buttons that calls the asset import load that we defined earlier in asset import 3. It calls the load function with the current asset. We want to package it up as a command and attach it to each button in the loop. And so that what happens is each one of these has a different asset attached to that import command ready to be used. And so we get that, package it up, now we have this function, and all you would have to do is say command. It's basically like a function. It's a function that, sorry, let's do that. It's a function that if we go to our load command, it's the load with this preset. So I think I've explained that enough. So we attach those in there, and then what this is up here and below is I hide the grid first before I add all the icons, then I show it, because it seems like a little bug where this does not refresh. And actually we can see what happens if we turn those off. Don't be scared. I am here for you. Here we go. refresh, refresh. Well, you're not seeing it now, but if you change the if the assets change, because these aren't changing, you'll get leftovers. Like if this suddenly disappeared and you refreshed, it would still be here. So you'll see it later in another example when we start changing the amount of objects that show up. So you need that for now. All right, so that's how the here we go. That's how the library side works. How does this side work that finds everything that's been imported? Well, when we hit this button, what fires? Let's look at our show. And when you click that button, what fires is refresh imported. It's another function we defined. Again, we're doing the catch-all for the args. And what we do is we clear out the imported list. It's a lot easier to clear out this because it gives you a remove all to clear out the list. And we're using the reference to the list that we saved in our show method. And then what we do is the function that we just defined in asset importer 3, find imported, now that comes into play. We get the node and the asset, and for each one of those we add it to the list. So if you remember back in here, find imported, it's going to run this command, tell us every asset that's been imported in the scene, and we're going to get it here, add it to this list, and that's how you get these built up when you click the button. And what about when you click on these and the selection in the scene changes? Well, if we go back to show, and we are calling import item selected. That's our third callback. Again, catching the args because we don't care about them right now. And what we do is we get the selected item from the scroll list by querying the list for the selected item, and it gives us back everything that's selected. If something is selected, just in case they clicked it and somehow there wasn't a selection, we take the first item that's selected only because we're not, you could allow multiple selections, but notice I can't even select no matter if I'm holding shift or anything. I set it up to only select one. So we just want to make sure this will still give us back a list. So we want to make sure we take the first item that comes back from that. If it exists in the scene, just being safe, then select it. So that's how this part works, like that. And the only other thing left in here is this little convenience method that we set up here. It's kind of nice. You don't need this, but what it is it's just a utility function that's here that automatically creates a window for you, shows it, and returns it. And that just makes it easier when you're packaging it up. I'll show you how that works. So instead of having to create this window and then show it, I could just say show. Let's get rid of the extra dot in there. And that just makes it nice when you're packaging up. It's not quite so long. So that's pretty much the basics of how to write a Maya UI wrapped around your commands. You would write your standalone sort of commands here and then wrap the UI around it, and they're very separated. And the nice thing about writing it like that is that we've separated the logic, the business logic, from the actual interface, and we can make changes to this module. We can import a different module. As you can see, we've versioned up, so we can just import the one we want and set it in here, and then all we're writing in this file is UI commands. And it makes it much cleaner that way because you don't have so much code to deal with at once, and it's much more portable. So that's the Maya UI. And next what we're going to look at is how to use Qt Designer, and I'll get into what that is and why it can make things a bit easier to design. In this chapter, I want to talk about the next step in our programming of Maya in Python. Up until this point, we've been using the Python commands module, and let's pull this up right here. We've been using the Python commands module, which is considered higher level programming because it gives you these canned functions, and basically this is what you're allowed to do, and this is what Autodesk has exported to the higher level part of Maya, and you can do all the UI stuff, and that's great. But when you want to have more control, say you want to create new nodes, you want to make a plugin that can load and be available to both Python and Mel, and just have more control over the undos and do all kinds of stuff. What we need to do is actually start using the Python API. And the way you can get to that is if you go to the help and go to Maya help, and I already have it up just so we have the right size window. You'll get this help screen, as you probably are familiar with, but then under the Maya API guide, you can open that in a new tab. Actually, and they've moved it to a new link, so let's open that in a new tab here. And this is the entire guide, and what this is the actual API itself is written in C++. And the people at Autodesk gave us a set of bindings for Python so that we can write the lower level code in Python, and you get this whole guide of how to work with it and all the things you can make. And it tells you here you can make dependency graph nodes, new shapes, you can write shaders, deformers, you can write your own file translators, and all of this is available in the code. And you have the entire reference here. And the thing that you'll have to adjust to is that while this is a lot more powerful, it is very much like C++ in the way you have to use it. It's very un-Pythonic. There's not as many objects. You basically have to pass things around to functions. Whereas if we look at our Maya commands, and for example this polyplane, when we've used this polyplane before, if I scroll to the bottom and we would create a polyplane, what we would get back is a list of the string names of the nodes. And then we have to always work with strings. So what happens in the API is, and if we go to, where are we here? If we go down to, just to take an example of the class list, it's a lot more convoluted. And for instance, this color, to represent a color, you know, it's a lot more type-based. You have to pass the right type of things to it, but we'll see examples of this. And because some people have found this to be a little more complicated, what's been created by a third party is PyMel. And in the last video, I had some feedback after the last video. Someone suggested that I actually should have talked about PyMel, and I didn't talk about it last time because I felt that, you know, because it's a third-party package, there's no point in teaching you PyMel. You could learn it yourself if you learn the Maya commands, and if you try to dive into the Python API a bit, you'll know all the concepts you need, and then you'll understand why PyMel would be useful. So I've pulled up the PyMel documentation, and you can get to it. If I go back to the help here, it's at the bottom, and you can pull this up. But now I'm just going to use this chapter just to briefly touch on PyMel. And what they've done is they've wrapped up the commands and the API into something that's more Pythonic, works like object-oriented. And what they've done here is they've created lots of inheritance the same way that this is exactly what, well, similar to what the Python API would look like. You would have a lower level dependency node, and then the polys inherit down the line until you get to a polyplane. So this is the polyplane similar to the polyplane in this example. If we were to create a polyplane with PyMel, what we get back is this polyplane object that has all of this functionality built in, getting the height of it, and scrolling down here, getting the width, subdivisions. Normally you'd have to use functions with the string name of the node to get the stuff, but they built it all in to where you get this actual tangible polyplane node that knows its place in the scene. Now, the reason that I don't want to teach this is because, in my opinion, and in some tests that I've done and other people have done, it is significantly slower than using the commands module or the API, for the reason that there's a lot more overhead to create all of this. Every time you create a polyplane, there's a lot more overhead that goes into it. It can be plenty fast enough if you're doing simple operations. But if you're doing anything that's highly looping and heavy crunching, you get a lot of overhead. Now that makes us it sets us up for the next test I want to do. What I want to do is bring up a script editor. All right, and I want to do a small benchmark, and this is the reason I'm doing this is because it'll let you see a little bit of what PyML looks like, and it'll help us segue into the API examples. So what I'd like to do, and let me pull up my snippets here, just to save us time. What I want to do is start with this concept, polyhelix. Let's just create this with some values that I've set up here. So we've created this helix with a lot of divisions in it, so there is a lot of vertices. If we zoom in here, there'll be a ton of vertices, and there's actually 20,000 vertices in this. I've already taken a look just for setting it up. And what I want to do is create a benchmark between the commands, the PyML, and the Python API to create this, loop over every vertice, or vertex, my mistake, every vertex in this, and move it randomly, and then delete this. And I want to see what that looks like. So let me clear out the scene, and let's build up this test here. So what we're going to start with is, and let's make sure that from our previous example that I still have my code in the path. Clear out here, and I'm going to pull up my code, and I've actually included, let me refresh this here. I've actually included this benchmark script. And so in this benchmark script, what we're going to do is we're going to bring in the Maya commands module, and then we're going to bring in PyML, and we're just going to bring it in under the PyML namespace so that we can see the difference, and then also the API. And this is one of the modules in the API. The Open Maya module has all the objects that you would inherit from, and it has a lot of the basic building blocks. So you've got these three modules. We're also going to need the sys module, the time module so that we can time our benchmarks, and the random module so that we can generate a random number to move each vertex each time we loop through. And then these are the same examples from the helix that I guess I moved, there it is, from the helix. I just copied them over into this dictionary so that we can reuse them for all of our tests. And then let's move down here to the first one. So I created a random generator in the top level so that we can reuse it. And I set the low to -4 and the high to 4. This is the range in which we're going to move our each vertex. And so here's the first test. This is using the commands that we're used to right now. The first thing I do is I grab the current time, and then I create the helix like you saw before, but I pass in the dictionary using the special 2 dots so that it expands to these arguments. And then I grab the first item in the list, which is the transform of the helix. That'll be a string name. And then I use polyevaluate with vertex equals true. I think that's vertices equals true, to get the amount of the count of them. And this should be, in this case, 20,000 about. It's actually, here's the number, 20,020 vertices. So we have this size, this number. And we're going to do a loop, and we're going to say for I in x range size. X range is the same as range, except it gives you a generator. I just like to do x range because it's more clear, and it should be faster. Although this might be implied, but still. And then what we do is each time we loop, we're going to get a random number between -4 and 4. Then we're going to build up our attribute, and the way we access the each vertex is with the name of the helix, and then the attribute is VTX, and they let you use these brackets almost like you're indexing an array, just like this, to get each vertex in the list. And there's 20,000 of them, so every time we loop, it's going to be 0, 1, 2, 3, and that's going to be the attribute name. And then we're going to use the move command to move it by our random amount. There's the attribute name, and we're just going to move it in the x-axis. So this is going to happen about 20,000 times, and then at the end, we're going to delete the helix, clean it up, catch the end time, and return the difference of how long it took to run the test. Okay, so let's move down and let's look at what it takes to do the same thing using the API, which is now new to us. I'm going to scroll down, and you're going to see that there's more code in here, and that's something that you have to get used to with the API. Is it takes more lines of code to accomplish similar things. So we still create the start time. We still create the helix the same way because this is already given to us. Oh, my mistake here. This was copied from another module. There we go. Let's make sure we're calling the commands module. And so we get the helix, and the same way, because this is actually a wrapper around the API, and it's already given to us for free, so there's no reason for us to try to recreate a helix. We want to keep everything the same. And then here's the part where it starts becoming different. In order to get the string name into a node, which the API requires, we have to create this selection list, which is kind of like an array, but it's how you deal with things that are currently selected. And then we create this empty M object. And this M object is a special object in the API where it's your handle to everything, all the objects in Maya, because Maya owns all the objects, and you create these M objects to refer to them because you don't actually own them, Maya does. So anytime you want to store a reference to an object, you have to create this M object. So we've got these two items here. We take the selection list and we add the string name of the helix to the selection list, and then the selection list has a function called getTheDepend node, and we want there's only one item in the list, so we want the first item of the list, and to store it in node. Now this syntax looks different than what we've been doing, and this is more C++ like. As opposed to it being node equals, much of the C++ likes to store it in the last value. So you would say I want the depend node of the number 0 index of that list and store it in this node. And you have to pre-create the node because you're saying turn this node into the depend node. And that's much different. You have to create things ahead of time in this API. Then we go down here and we're going to create a vector using mVector. And a vector is just going to be our point because we need to supply x, y, z, and this is how we can store x, y, z. Now the next thing you have to do is to loop over every vertex in the mesh. We have this iterator, and this is where the API excels because it gets faster. You're doing this C++ style as opposed to a for loop in Maya and pulling out all the names of each vertex. So we've got this iterator, and this is anything that starts with MIT is an iterator, a special way for us to loop over whatever it says, mesh vertex in this case. So we create our iterator off the node that has the name of the helix, and we get back this iterator object. And the way you use it is you say, while it's not done, because this is pointing already at the first item, the first vertex in the iterator. And the way we increase that is by calling next. Every time we call next, we get the next. This becomes the next item in the iterator. So we just say a while loop. While not this iterator is done, so as long as this iterator is not at the end, we're going to create a vector. We created the vector once, and we're just going to set the x position to a random point. And then we're going to use iter translate by that vector. So every time this loops, it's going to get a new random x and translate that specific vertex by this amount. Then when we call next, this iteration advances one spot to the next vertex. So this is going to loop until there's no more vertexes. And finally we call delete node, which is similar to commands delete, but we're using this mglobal, which is a lot of utility functions that you can call, and you just pass it the node. It looks very similar to commands delete. You can just pretend that there's the global in there and it's almost the same. And then we just close off our time and return it. So you can see that's a lot more code to get from here to here, and it's a little bit new and obscure, and that's why we consider this point starting to border on the advanced level, because this requires you to start thinking in terms of C++. Now let's look at PyMel. Let's go down here. Now you notice PyMel is very little code, and that's where the strength is. That's what the push for PyMel is to be able to write less lines of code to achieve the same results. Now what PyMel is doing, because it wraps up the API and the commands module, we'll start with the time, we'll create the helix the same way, but we're using, now notice, the PM module. We're now using it through PyMel. So instead of getting back the string names, what we're going to get is objects. These are now objects. So what's cool about that is, now that you have this, you can actually just reference the vertex list with .vtx, and that looks very similar, if we go up here, to this, but we don't have to do it with strings. We have a function. And as far as I know, it seems that this might be using an iterator under the hood. It might be using, I haven't looked at the source for it, but I'm assuming that it would be setting up one of these for you and doing this functionality for you. So we're just going to say for v in the vertex list, and then you create a new vector. Now they've wrapped up mvector under their data types, so it's the PyMel core data types. You create a new vector, and we pass in the x value is a random number. And then we call translate by, and you can see these two lines are very similar to what's going on over here. We create a vector, and we use the translate by to pass the vector. Now you can see that up here I'm creating the vector first, and then I'm just updating it every time, so I only make one vector and I update it. That should be faster here. For some reason in PyMel it's slower if I create the vector right here and update it. So if I create the vector every time, somehow it's slightly faster. So we'll just go with that to give it the edge. And then again, a lot of the commands modules are right here at the top. So if this were just commands, it looks exactly the same. But we'll just make it PM. You pass it the object, it will delete it. We close off our time. And the last thing I have here is just a convenience test all. And what this is going to do is it's going to write what it's testing, and it's going to flush. It's doing it this way so that you see a printout after every test, so it doesn't wait until all the tests are complete to actually print. So we print, we run the command, and we get back the time, and we append that to our list. And we're going to run that 3 times for, and what I'm doing is I'm getting the results, and I'm also attaching a name, and I'll show you why I'm doing that. Once we get our results at the bottom, I'm going to sort the list so that the fastest time is at the front and the slowest is at the end. I'll pop off the fastest, and then I will just print the fastest and then print the rest of them and calculate their offset speeds. Alright, so now we understand the benchmark we're going for. Let's pop over to Maya, and again we've got our code path on the Python path. So if I import benchmark, right, I've got the benchmark. Let's actually, and you'll notice when you import the API and PyMel for the first time, there's a little bit of a delay while it loads everything up. So to do our test, what we have to do is do test all. Let me clear this. And you're not going to see anything here because it's going to create and delete it. And you're just going to see output right here. So I'm going to run this, and it's actually going to take a slight bit of time, and you'll see your pinwheel for a little bit because, again, remember it's going over 20,000 vertexes in the mesh, and you can see it's finished the commands. It's working on the PyMel right now, and that should finish up pretty soon and actually start the API, and then we'll get the results. And this will actually illustrate another point of mine about when to use each type of API, the commands, the mel. So here's the results. API is the fastest, 7.8 seconds. The commands comes in next at a little over 10 seconds, which is 1.29 times slower than PyAPI. And PyMel, 15.4 seconds, almost 2 times slower than the API. So this illustrates a point that where the benefit lies. If we look at our code again, here's where the benefit is. Writing less code and having it being more object-oriented, being able to create this helix and having this helix have its own functionality to check things about it, its width, and doing get attribute on it. But where it tends to slow down is when you have to do a lot of looping, crunching, heavy work. There's so much overhead in in creating these nodes. Every time it creates this vertex node, every time you get a vertex, it's creating a vertex type node, and there's so much overhead involved. So obviously when you have to do something extremely fast like that, the API is your best bet. And you can even intermix, which is great, is you can intermix the commands modules as I did, because there's no point in reinventing this. So the other thing I want to show you is I added this little part in here where we just set the subdivisions down real low so that we only have about 3,000 vertices. And I'm going to go ahead and reload this, and I want to show you the difference. I'll clear this up. Actually, I'll leave it up so you can see the difference. So let's run this again. This should go pretty fast. So as we're waiting here, hopefully I didn't even save it. Alright, well, I guess we're going to wait for a second. I'm allowed to make a couple mistakes in this video. So let's go ahead and save this and wait for our results here. And what I want to show you basically is that as you do even less loops, you can see that there's even a bigger gap in the performance of these tests. This should be done in just a second here. Okay. And you can see, again, this is showing you how consistent it is. You get the almost the same numbers. So if I reload this, and we can make sure that it picked up our change because it says py at the end, and I run this again, this should go very fast. Now you can see here a huge difference. This was only doing 3,000 loops, and Python was, or the commands module was 2 times slower, and PyMel was 5.5 times slower because of simply just the overhead, and just as well for the commands too, in creating, working with strings so much here. It's probably a lot of this working with strings. That's the overhead. And for PyMel, it's just creating those nodes is, devastating in terms of speed. So you have to make that choice in what you're going to code if you want to go with speed or if you want simplicity. And there's different reasons to go each way. So that being said, you can see why there's no reason for me to teach you PyMel, because if you go over the API and you learn this, which is still important, you should learn this anyway, because that's how you get the nodes into the core of the system. I mean, you have to have PyMel to use the PyMel features. So if you learn this, then PyMel is the same syntax, just in a more Pythonic way. Alright, so we've got that done. Let's hide this here. And the last thing I want to do in this chapter is talk about how to set up your environment to start working with plugins. And you'll notice if we go into our code here, in this plugins directory, I've got our next example uh, is a plugin, and I've also dropped some code into these subdirectories. And I'm just going to show you how to set up specifically for these, but you could do it for a facility location or your general projects location. So let's pull up a shell. And if you're on Windows, you can do it through the Explorer if you want, but I'm going to do it through a command line. And I'm going to go into, on a Mac, it's Library, Preferences, Autodesk Maya 2012. And we've got this here. And I'm going to go into my Maya env. You can edit this in a text editor if you want. And what we want to do is a couple key flags, environment flags. First thing we want to do is set up the Maya plugin path. And this tells Maya where to look for plugins. And you can do multiple paths. What I'm going to do here is I'm going to move this up here, move this down. I'm going to say this is my plugins location. If you wanted more, you would just add more paths separated by a colon. I'm just going to do one for now. And the next thing I'm going to set up is the Maya script path. This is where it should look for Mel scripts. And again, you can put in multiple paths, but for our project, I'm going to put in Mel. And the last thing we want to set up is the Python path, and that's where Maya should look for your Python scripts, not plugins, but things that you would import, similar to the way you import the commands module, or it would find our asset importer if you want to set this up. So I'm going to set this up again right here. And what you want to do here is so that you don't override completely the complete Python path, we should add in the Python path variable. So it's basically going to tack our location onto the front of the existing Python path, so all your other stuff will still be found. Now you can use this to set up your own location for all your code, but for our purposes, that's all we need to do. Alright, and so I'm going to hide that and hide this, and I'm going to restart Maya. Close this down here. Alright, so, and then open Maya again. Alright, pull up the script editor here. And now we'll see, if we go to Window, Settings, Plugin Manager, we now have, it has our new location. It sees the plugins that we have in there. I'm not going to work with them yet, but this is how you would load them in, like that. And if you don't get any errors, then you didn't screw up, and it came in. And for now, that's going to be the end of the chapter. In the next chapter, we're going to get into the API and take a look at how to write a node. So when we last looked at the asset importer, the last thing we did was we created a UI for it in the Maya UI code. But ever since 2011 Maya, when they rewrote the UI, the interface here in Qt, as you notice the interface is much different, they also let you write your own UI in Qt using a tool called Qt Designer. Now you have to download it, but this chapter is going to show you how to use Qt Designer so we can redesign our asset browser interface. So I'm going to pull up my browser, and let's see here. Okay, I've already got the site up. It's qt.nokia.com because Nokia owns Qt. And what you do is you go to the download section, and you can do this if you want to pause it and do it, or do this at a later time, but I'll show you how. And you want to go down to, you want the Qt libraries, but instead of getting the newest version, we should get a different version, and I'll tell you why. If we go down to the FTP archive at the bottom, it's kind of hard to find these versions, but I'll explain why I'm doing this. We want to get the same version that Maya is using, because what that'll let us do is if we go to the source directory now, we're in Qt source. Let's pull this up, and I'm just going to find what I want is, I want this 4.71. The reason I want this version is because that's what Maya 2012 shipped with, and in order to use later on, if you want to use PyQt, which lets you write UIs completely in Python, you'll have to build it a certain way, and I actually will go into that later in a bonus chapter, and I have a blog on how to do that. But if you get this version, you'll be sure to be set up for that step if you choose to actually go down the route of getting PyQt installed. So you would download this file, install the library, and what that gives you when it's done installing is a tool called Qt Designer. And you can find this installed after you're done. And when you launch it, it comes up with what you want to start making. In our case, what we want to start making is a dialog without buttons. So if I hit create, we get this blank slate. And I can resize this. And what we got on the left here is all the different widgets we can use, the properties for the selected widget, and up here is the hierarchy of what we're building. Now, when you build a UI in Qt Designer, there's some limitations because Maya is only going to recognize a certain amount of widgets to convert them over to the Maya objects that we looked at before, the things we could access, and the ones it can't understand you do not have access to in the code in the commands module. So let's build this a certain way, and I'm going to show you again why I'm choosing to do certain things as I do them. But let's go ahead and set our width of the dialog at 1000. Let's set this at, actually we'll make this smaller. We'll resize it later. Since I have limited desktop space, I'm going to stick to just not resizing it at the moment. What we should do first is we should set the name. Again, forgive my limited space. The object name, we want to set this to asset importer window. And what Maya will do is once it imports this, this will become the object name of the window as we had previously set it in code. This will be the object name of the window. All right, and then we can go ahead and set title under window title. We'll call it asset importer. Okay, so now we want to start bringing in our widgets. And if you remember from the previous example, we had our grid library over here, and we had our imported list over here. So let's start laying out some stuff. Let's bring out some buttons. Okay, and let's call this one, this is the refresh library. Can make this a little bigger. Let's call this one, this was refresh the imported list of what's already in the scene. And then what we want is, you remember we needed to do a scroll over here and a list over here. So what we can do is we can find a scroll area. Let's set up a scroll area like this, and let's get a list. Now make sure when you get a list, there's two types. Make sure you, let's do the list widget. Okay? Set it like that. Now don't worry about positioning them too much. And so what we can do right off the bat is we can say, let's select these two, and we have these ways we can lay them out. Let's put them in a column view, like that, and let's put these in a column view. And we can actually make sure this doesn't get too wide. We'll go click on this, and there's a maximum size. We'll just call it 150. There you go. And we can do the same over here. It's currently at 138. We'll just say, let's just keep it at 138. So that when this resizes, there we go, like that. And then if we, with nothing selected, we can actually set another, let's see right here, make this a little wider. Doing our best to work with the space. We can right click on here, and we can say layout, and let's lay everything out in a grid. That's fine, a grid form will work for us, and it automatically pops everything into place. So now we've got the scroll imported. Now let's make sure we name this because we need access to some things here. Let's name this one first. This is the imported list, so let's call this imported list. Alright, so now we've got our list, we've got our scroll. Now you'll notice right now scroll has an automatic child, which is the contents. It's an invisible widget in here, and it's got a symbol on it because it currently has nothing in it and there's no layout. So what I'm going to do, and this is kind of a workaround, and I'll show you why in a bit. I'm going to just drop a button in here, and I'm just going to call it Delete Me. And I'm going to set this button to Delete Me. Now, I'll explain this in a second, but now that we have this in here, we can just do a column layout. All I'm doing is clicking on this scroll, right click, layout. Let's lay out vertically. Okay, so it's in there. And let's go ahead and rename this a shorter name. Let's call it scroll. Okay, so we've got a scroll area with the main content for the scroll area has a child called Delete Me. And the reason, let's also make sure to rename our scroll area. Let's call that, let's see. Let's call it library. Okay. All right, do we have all our buttons named? Oh, we missed one. We got to call this one reload imported button. Okay, call it reload imported button. So now we look up here. Do we miss anyone? Oh, we got missed that one too. Let's call this reload lib button. All right. And okay, so now we've got everything laid out. And the reason that I put this, oops, not to save this yet. The reason I put this in here is because something I've found in the way that you use the UI. If you don't have anything in this empty UI, it's not going to export it and make it accessible to you. So I found that you have to actually have something in there because we want to fill this grid later on, but you know, we need something in there, so we're just going to delete this later in code. Okay, so now we've got this UI set up, and some things that it lets you do, though we're not going to really do it in this example, but I want to show you, is you can actually add Maya commands functions to the end of how it should create this button. So you remember that this has a -C, or you could say -command flag, and what you could do is you could actually click on this button and click on the plus, and we're going to add a string property. We're going to create a new property, and now the way you do it is, if you were doing this in Mel, you would say command, but for Python, you put a plus in front of it, and it tells it to do this in Python. So we say OK, and in here is where we could do, you know, commands.sphere, or you know, any kind of call that you want to make. Now, I don't want to do it this way because we want to hook these up later on, but you could add all the properties from the commands modules like this if you want to set up your widgets directly and not have to do anything later on. But we want this a little more dynamic, so I'm not going to do that. I'm actually going to delete that. And at this point, this is just an example. I have actually created this file for you, and it's actually located. Let's pull this up here under code, asset importer, Qt, and here is this file. This is for you to use, and this will be part of our example. So the structure that we have under here is we have our UI file and we have our asset importer win, which is exactly like this one, but we'll actually look at the difference of what we had to change in the win. So what we'll do is we'll pull up some code here. All right, and let's go to our asset importer and go to, first we're going to open our original one. Let me close some things out. Okay, so let's look at our first one here. And if you remember, what we had to do is, you know, we imported our asset importer 3, and we created our asset importer, and we had this show function, and we had to actually make our window, make our layouts, make our buttons. And you remember, these are the same names that we just gave in that Qt designer: library, scroll, imported buttons. We gave all the same names so that everything stays the same, imported list, but we didn't have to do any of this. Let's look at this new version here. Alright, so in this new version, staying the same so far, what I did here was I'm setting another class level attribute to the path, the full path to that UI file, which is in the Qt folder. But for the purpose of this example, I'm also using this special version that will relatively find it to this file so that you don't have to worry about paths, but you could just set the full path right there and comment that out. But we'll use my version for now. So this will find it in the same directory. The init is relatively, actually should be the same. Let's look at the differences between those two. They should be the same. And moving on here, asset import window is the same here. Now, instead of the whole creating the windows shindig, we use the commands load UI, and we load, the file is the UI file that we set right up here. And that will automatically generate the window for us, so we have the entire window with the entire UI. The only thing we didn't set up, and this is the bit of the hack that I was talking about, is because we want to be able to work with a layout tangibly, whereas in Maya you would work with widgets in the layout, but we want to add dynamically. So what I did here was I got the path to the library layout, and that's actually the name of the window, main layout, library frame, library layout. Now, how did I know to use this path? Well, let me show you what I did here. Okay. And what I did here was I loaded in the window, right? And I got the name of the window. And then I did a loop. And what I'm using is the LSUI, which lets us list UI components. And I have a flag here that says dump all widgets, and this will dump every Qt widget in the scene. And I say if that specific widget has our window name in it, print it, and you'll see what happens here. We get a list of, these are all our widgets that got made for us when we made the widget, the window widget from the UI. And if you see here, here's our delete me. Now, when I said I had to put this in here, if I hadn't put this button in here, you tend to not even get these layouts exported. So we need where this location is to start adding our all our assets. So let's go back over to the code here. And so what I did was I got that path, and then I'm going to create my own grid layout in the space where the button is. So, and I call it library, just like in our previous code. We had library creating a grid layout. It's exactly the same thing. And I parent it to the library layout that I just found. And then I delete that button. So you see why I had to make a placeholder. If I hadn't, I would never have had this path to reference. It's kind of strange like that. And then that's all I do is I just save the window, the library, and I have this new little function here. This is new to this file called getUI. Let's jump down here and see what it does. This is just a special little helper that helps me find the widgets, the UI widgets, by name. What it does is it's that thing I showed you before where it gets the dump of all the widgets, and it looks for every item in the list if it's part of our window, and if it's part of our window, then we grab it. So this gets all our widgets in the UI, and then I go through each one of those items, and if it ends with our name here, then I grab it. So it's an easy way. Let's go back up here to show. For me to just say I want the imported list, because if you remember from our Qt file, this is our imported list, and I just want to get it by name. So now I can just say get UI by name, and now I've got the widget, and that's very similar to where we just created our imported list from a scroll list and then saved the name. And then down here I set up my connections, and just like before, I set up the button and I get the UI. Instead of knowing the name ahead of time, I just get it from the name we named it in the Qt file, and I point it to refresh assets. So this part is all the same. If you see that when I switch over here, this is all the same. All I changed was how I got the name. Instead of having to create these by hand, I just grabbed the names of them and connected them. So all the code, except for this new function, all the code is all the same. I never had to change the way that these refresh assets, refresh imported, that's all the same. And it reduced our code significantly and made doing the layout a lot easier. All I had to do was load the UI file, and in the case of our application, just create a couple more nodes, and that's it. And let's take a look at what that actually looks like. I'm going to create a new scene here. Just make sure we're good to go. Clear this out. All right. And if you remember, we've got our path, okay, on there. And the location of the file, if we pull up our Finder, is now we've set code to be our path, so it's asset importer Qt, and then asset importer win. So let's do that. Let's say from asset importer .qt, and let's look at this again. Asset importer win, asset importer win, import asset, and we called that, let's check and make sure, always have our code as a reference, asset importer win. Alright, now we've got it, and all we have to do, dot show, let me hide this here. Oh yeah, that's right. We didn't set up the show function. We don't have the convenience show. Let's just create our own instance of it. So let's say, oh, that's because we imported the actual class. All right, we'll just do it like this. We'll say win equals. We could have imported it up to here and then said show. But let's just do. Now we've got an instance of our window, win.show. And there we go. This is our asset importer made in Qt. Let's see if we can make some room here. And some differences is it's a lot easier to set up the way that the layout works and attaches to everything, as opposed to having to do convoluted UI commands. And let's close this here. And you can see it works just the same way. We can refresh our library. We get all our assets here, and we can import them. Sorry, my Maya had a little bit of a problem. I just had to restart it, but we're back to where we were with the imported items. But we can hit this button, and we get the list, and we click on each one, and it changes the selection. So you can see that the functionality is all the same, yet it was much easier to create a UI. And you can imagine if you wanted to create much larger interfaces with rows of toolbars and lots of widgets, and it's so much faster to create your UIs with Designer, even with the ability to set, like we said, the dynamic properties down here at the bottom, which the Autodesk videos kind of show you how to do, but I kind of find it somewhat limited. So you can only do so much with this, but if you really want to blow the doors off this whole thing, you should move into the idea of using PyQt, which lets you define all the connections, all the buttons, everything through signals and slots, which are ways to hook up events to callbacks. And we'll get into that in a bonus tutorial. But this was how to create the Qt Designer. You can download it and give it a try. This segment of the tutorial is where we start pushing into the advanced category of Python and Maya, and that's because we're going to look at the API. And the API, like I said in the previous chapter, is very C++ style. It's less Pythonic, so it takes a little bit of adjusting. So I think we're going to start with some very simple API examples and not really get too deep into it. That can be some sort of later video. But what we'll do is we'll pull up an example, and in the code plugins directory, the first thing we want to look at is the simple command. And let's pull this up here. And there's a couple different types of scripted plugins that you can write. And the most basic of all of those is a simple command script. It's very similar to all of the other scripts we've written. And the only difference is that this gets loaded in as a plugin, and it would be available on the Mel or the Python side as a very natural command, such as if you were to write commands.myCommand, you would have access to your plugin in that form, as opposed to having to do a long import statement and make your objects. Maya loads it as an actual native plugin. There's a couple extra reasons that it's beneficial, is that you get more access over the undo, redo type system, and but pretty much you're not going to get a huge benefit because you can still use these in a normal Python script. So let's just take a look at it. What this is not a complete script. This is a template that I put together so that you can see with lots of comments of what everything does. So let's go through this bit by bit. As you saw before, the way to access the API in the Maya, instead of using the commands module, we can use Maya, open Maya, and we'll just bring it in as open Maya namespace. So now we have access to, these are where all the objects live, the various objects. And then open Maya MPX, these are all the proxy objects, and we'll see what those are in a moment. This is what we template our new types of objects off of. And then we'll need the sys module, the standard Python sys module. So one of the first things you do when you're writing a command plugin is you would define some constants, and the C++ form of doing that is putting a k at the beginning of your variable to note that it's a constant. And right here we're just giving it a plugin name. This could be anything, but for readability we're saying k plugin command name. We're going to call this command a simple command. So we start our class, and we can call this again anything we want. I'm calling it simple command. And what we inherit from to create a new command is in the proxy module, there's the MPX command, and this is the base class for creating a new command. And what you always want to do is define your init. Even if you're not going to do anything here, you need to define the init and call the superclass so that it gets set up properly. Now, one of the most important functions, the methods that you need to know about in a command is the doit method, and it has to be case sensitive just like that. What you're doing is you're overloading your own doit, and this is at the very, very basic level where you would do everything, all your functionality. You get the arguments coming in through here. Maya gives you all the arguments from the selection, and then you can use those. You can parse the arguments and run your actual command right here. All I'm doing in here is I'm just writing out to the script editor, just that we got into the doit method, and that we would be, and then it's just going to print hello world. Now, if you wanted a more advanced plugin that supported the undo functionality, what you would need to do is you would define this undo method is undoable, and it just needs to return true. So if this were a command that supported undoing, you would just need to return true, but I'm going to put it false, or we don't even need to have it here, but just for your readability, I'm putting it right here. And that would be really at the basic level, all you need is this. And what you get is, and let's take a look at what that does. Now, if you remember, I'm going to pull up my shell one more time. In the previous chapter, I went into my Maya env, and I set up these basic environment variables. And so we have the plugin on the path. So I'm going to go back into Maya, and I'm going to pull up the plugin manager. All right, and so we have, it sees some plugins in our path. I'm going to load the simple command and close this. And you can actually hit info, and it tells you what command came in. So this is the command that came in, simple command in those caps. So if I do commands.simple command and run this, you see what happens, that I can run this just like any other native commands module command because we created a new one. And all it does is it prints these two lines that it got into the doit method and then it ran hello world. So let's look at that again. These are the two things that happened. It takes care of everything else with the function or the setting up, and it just calls this for you, as opposed to you having to call any kind of functionality. Now let's go down here at the bottom and look at the other required elements of a command script. These are boilerplate commands. Let's give you a little more room here. You could basically copy and paste these into any command that you're writing. The default things you need here is this command creator function, and this is a function that Maya is going to look for specifically in order to know how to get a new instance of your class. All it has to do is use this Maya proxy as Maya proxy pointer, and it just creates an instance of our class from up above and returns it. And you can pretty much just copy paste this, switch this out for your class name, and you're good to go. Then this is optional. This is a syntax creator. If your plugin, if your command takes any command arguments, then this is where you would set all that up. And I'm not going to do this right now because it's not really necessary to get into this, because if we wanted to write this function for our asset importer, pretty much all we would have to do is just paste the functionality into here and make doit call the asset importer. We don't really gain anything. But you can see this template is how you would set up a command. And this is the area, again, where you would define flags, but we're not going to do that for now. I just want to show you the template. And it returns a syntax object. This syntax object would, under this section, be populated with your flags. The last two pieces of necessary functionality is the initialize plugin and the uninitialize plugin. These are called when the script is first loaded, that is, when we go into the plugin manager. When the script is unloaded and loaded, that's how it initializes and uninitializes the plugin. And again, all you have to change, what it uses is the proxy class. It defines a plugin and it wraps an M object, which again you don't need to worry about. But right here is where you could say the author, the version of your script, and the API compatibility that it requires, but you can just leave this as any for now. So really all you would change is these two things right here. And the rest is boilerplate. This is registering the plugin by the name that you gave it. See, this is where we define the name. If we go back up to the top, this is how it gets the command name. And we just pass that right down here, along with our command creator and our syntax creator. So it completely knows how to register this plugin. If it can't register the plugin, it's going to fail out with the name of the plugin. Same thing down here, and there's actually nothing to edit. So if you were just to copy and paste these, you're good to go, and just fill in the doit section right here. So next, what we're going to look at is we're going to create a new node. And again, we're going to take this up a notch, and we'll just try to follow along and keep it really simple. So let's go ahead and let's open up the other file that we have in here, the shake node. And there's a lot of documentation in here as well for you to look at later. But let me go through what this is going to do. Actually, I'm going to go ahead and load it in and show you what it does so that we know what we're talking about here. So I'm going to go up to the plugin manager, and I'm going to load it. Now, if you set these to obviously to auto load, you wouldn't have to keep doing that. And let's go ahead and get rid of this. So what I'm going to do here is I'm going to say shake equals commands create node. Shake node. Right? We create this, and what we get is this new node, and it's called the shake node. And what we've defined on this shake node is amplitude XYZ, frequency XYZ, an attribute called octaves, and an attribute called random seed. And this is a dependency graph node. It's something that you can connect the output of to the input of another function that would receive an XYZ attribute. And what this would do, and I can go ahead and paste in an example here for you to check out. Okay, and I'll explain what this does in a moment. So what I'm going to do is I'm going to just run this, right? And let me close this for clarity. So what we've got here is a sphere. Let's put this in, see a lot of frames here, and let's see what it does if I hit play. You see that this is shaking around here. It's modifying the position. So let's find out. Let's open the script editor here again, and let's select the shake node and take a look. And it's connected to the time module, so it's constantly getting the current time, and it's shaking it over time. And let's select the sphere again and see where it's being driven. So you can see right here, these attributes are being driven. If we stop that, you see that the translate's connected to it. So this is just a very generic node, and if we open up the hypergraph connections, we can see that we have the shake node connected to the NURB sphere translate. Let's open this here, right? So all we're doing is creating a dependency graph node. It does not show up in the DAG. It just shows up in the connections. So let's take a look at what the code actually does. Okay, so this is a dependency graph node, and what we're inheriting from in this shake node is in the Maya proxy module. It's called MPX node, and if we open up our documentation that we had earlier from the API reference, and if I go over to search and I search for the MPX node and I pull that up, we find out that the MPX node, it's the base class, the base parent class for any type of dependency node. So any kind of new node you're going to make, you can inherit from that. And here's a little graph showing you how that's laid out. You have the MPX node and all these other types of nodes that inherit from it, and then nodes inherit again from those. So if you wanted to get more advanced with a transform node, which we were actually kind of making, you could inherit from this, but we want to just try the most basic approach. This is at the very least what we need to inherit from. So let's open up the code again and go through this here. So here is again where I set my node name, and you can see that this is slightly different. I could call this anything I want. It's a plugin node name. We're going to call it shake node, and we need the OpenMaya and OpenMaya MPX as before, and then I've got the basic math, sys, and random, and we're going to use the random module to generate random shake. And if I could just give you one more example, if I actually I don't even need to uncomment it. I'll just select this, and I'm going to select the sphere, and I'm going to bake this out. Let's wait for that to be done. Okay, now let's take a look at the graph that it produces. You can see that what we're generating is a noise curve, and with randomized points. And what happens is we have the large scale randomization, and then we have these finer randomizations. So we want to be able to control large frequency and the smaller frequency. So this is the goal of what we're trying to produce here. And you can see that the X, the Y, and the Z are all different randomizations. So we want to keep those so that you don't get the exact same motion on all axes. Let's go back to our code and see how we do this. So the next thing that we need, and this is required by Maya when you are defining a new node, is you have to define this type ID. And what the type ID is it's a hex number, or just a large int number, and we can see the definition of that in our documentation. If I go over here and I search for the mtype ID and take a look, we'll see that what happens is this range right here, these first amount of IDs are internal to Maya, and that defines all the nodes that Autodesk has provided. But then you have this other range right up here, another set of this many IDs that are for development to create with. And for our purposes, if you're internal, you can use any of these numbers. So say you're developing at your company and you're not going to be distributing any of the scene files. It's all internal. You can take any of these for your internal use. But if you're going to be distributing to everybody in the world, then you have to actually contact Autodesk Developer Network like this and request a block of IDs that they give you. And the reason for that is because when these nodes get written to scene files, they actually get stored with these IDs so that when you go to open the scene again, it looks at the ID and it matches it up and makes sure that it's actually using the right node. Because if it were to use, say I have a node called Shake Node and someone else writes one called Shake Node and they open it up, their Shake Node may not be like mine. And it may not work and break the entire scene. So if they do it by ID, they know that if these IDs match, then it's the right kind of code to expand this out to. So we create our ID, and then we come down here and we inherit from MPX node. And the first thing I'm going to do is set up some attributes for my node. And if you noticed in Maya, if I bring up my node here, let's see, select Shake, we've got these attributes that we set up. And we define those slots right here as class nodes, and we just set them to open Maya M objects. And M objects, like we said before, is the most basic handle to an object that Maya would own. So these aren't set up yet; they're just handles, and they're here to be set up at a later time. So these are my input attributes, and then I'm going to have one output attribute, which is going to be an XYZ data. So we set up another M object, and as usual, we inherit from the superclass, which is from MPX node. And then the most important item that you need in your node is the compute method. And what compute is whenever a plug on your node is needs to be evaluated, it will call this method with the plug that's in question and all the data that's available to you about all the attributes at that moment in time. And the rule of thumb is that when you do this compute method, you're only supposed to use data that was given to you from this data block. You can't be calling out to other scene data because you don't know what moment in time that it's valid. So all your data needs to come in through this data block. And what we do is, in our case, the only plug that we care about checking is the output. We only want to know if we only need to compute the output node. Everything else is going to be set from another source. So we say that if the current plug is self.output, because we're checking if the plug being given is equal to this attribute, then we're gonna use it. Otherwise, we're not going to do anything. So this is the only case that we use. And this is where we grab all of our data about this current moment in time where we're computing something. We look at our data block and we ask for the input value, and this is where these attributes come into play from up here. We set these handles, and so we're going to use these handles to pull out our data. So we say input value for this attribute, and we need to convert it to a float 3. And I'll explain these coming up in just a second. So we want this to come out as a float 3. We want the frequency to come out as a float 3. Time is a time value. Octaves is an int. Seed is a long integer. And seconds is where we take the time and we convert it into actual seconds. So let me give you a little more detail on what's going on here. Let's move this over a bit. Actually, let me jump over here. What you can see is that amplitude has 3 values. This is a 3 float attribute. So if I want to get the results of this amplitude, I need a 3-part float as a tuple. And then same with frequency, I need a 3 float. And then for octaves, it's only integers. So I just need 1 integer. And again, I need a long because this could be a very large integer. Now, where does time come from? Well, time is attached as well and being driven, and I'll show you where time comes from in just a second. Okay, so before we go any further in here, let's jump down to the other needed functions before we get into how this node actually works. Just like before in the simple command, where we had a command creator, for a node, we need a node creator, and it's the exact same thing. It just needs to return a pointer to an instance of your node, and you could have called the class anything you want, but it's going to return an instance of our shake node. And the next thing we need is the node initializer, and this gets run once when the entire class is getting set up, when the plugin is being loaded for the first time. So this is where we actually create and set up our attributes. Before they were placeholders, but once the node is actually ready to go, it can actually get its attributes set up properly. Let's make some more room here. Okay. All right, so the first thing we're going to handle is our inputs. And the way we do that is we have to, from the OpenMaya module, get, and you'll notice that these MFNs, these are all function attributes, function modules, classes. And what we get here is we need a numeric attribute creator, and we also need a unit attribute creator, and this is going to be for our time, and this is going to be for all our other numeric attributes. So you get these creators. And then what we do is first we're going to say we need to set up our amplitude on our shake node. So we say from our numeric attribute, create an attribute with a long name called amplitude, a short name called amp. The value type of this attribute is a float. And to explain this format here is from the OpenMaya module, from the numeric data, we need a float. Actually, we could have written this shorter, like that, but I want you to see where these come from, because this is an instance of a numeric attribute, this also has those constants. So let's just put this back, and you can see, oh wait, my mistake, I'm sorry. This is a numeric attribute. This is a numeric data. And this is the class that actually holds the constants, my mistake. So as you saw before, k is constant, 3 float. This is just a constant number that tells it that the type is a three position float. And again, we do the exact same thing for our frequency. Long name frequency, short name FREQ, and then we need a float, and these are defaults. So if you don't specify this, all the values are 1. If you don't specify the attributes for the frequency, all the values are 1. And now we need a seed, and a seed is what we're going to use for our random generator, and it's so that it's only pseudo-random, and if you specify the seed, you can get the same result back every time, because if you produce a result and you're animating to that, or you're keying off that, you need to be able to reproduce that functionality. So the seed lets you control the exact results of the randomization. Each new seed would be a different set of randomization. And before I go any further, I have to explain these parts here. Now, each time we make an attribute, we can set some options on that attribute. And in this case, for the amp, we want it to be able to be storable in the file. So when you save the scene, it can actually write the value of the amps to the file. So when you bring it back out again, it doesn't go to default. It actually sets what you saved it at. And you also are allowed to keyframe it. Same here. We want to write it to a file, and we want to be able to keyframe it. Same here, except we don't want to be able to keyframe the seed, because if you keyframe the seed, it's going to really make your results crazy every frame. So there's no point in keyframing it. So we're just going to disable that. And we're going to say that the minimum value is 0, because we don't need to allow negative numbers. We'll just do anything positive. And now for the octaves. I'll explain what the octaves are in a moment, but in general, they control the smaller and smaller levels of randomization. If you remember in the, let's open up our graph editor. If you look at these, you have the large randomizations, but then as you get closer, you have these smaller. This is not quite a smooth curve, and neither is this. We're adding smaller and smaller jitter, and it makes it a little more realistic if you want to add more and more jitter, but you have control over that. So we say octaves, short name oct. It's a numeric data, and then this time it's an integer. And the default we're going to say is 3 octaves. It can be stored with the file. It's keyable. And we're going to say the minimum is 2, because if you go any lower than that, you're basically just going to have a really smooth curve. We could allow them to go to 1, but I think 2, for our purposes, let's say that's the lowest it can go. And now also now we have to get the time. Now you notice we're going to use the unit attribute from up here. If we're using numerics before, now we're going to use a unit attribute. And we're going to create a current. Time is the long name, time is the short name. From the unit attributes, it's a time format, which is actually another type of object. So when we get the value of this, we're going to get a time, an mTime object, as opposed to these concrete values like this. We're going to set it to hidden because they don't need to see this value in the node. It's just for our internal use. And it's not going to store it either because it's completely driven by an outside source. And then the last part is our output node. So we set the reference to the output. It's a numeric attribute called output, short name out. Again, it's a numeric data, a 3 float, and the default is 0, so that at a very default value, it does not do any kind of movement. And it's not storable, not writable, and it's not hidden. Because we don't want to store the output of this. We want it to be computed from all these inputs. So even if it gets written to a file, these will still just get generated again to drive this output. Then after we define all of these, we have to actually add them into our shake node. So we use the shake node, and because we inherited from MPX node, we have this add attribute, and we just add all of these attributes into the shake node. It kind of registers them. So we have a handle to them, but it's also registered as part of the node. And the last thing you can do is talk about how you want one attribute to affect another. And this is where we were talking about which node will come in the compute method. So we want to say that every one of these inputs, the amp, the frequency, the seeds, the octaves, and the time, all affect the output. And what this means is the concept of dirty and clean. So if we go back up to our compute, I'm going to jump to the compute method. When a plug, which is a attribute that holds the data on a node, a connectable part, is dirty, it's going to be reevaluated. And in this case, we only care about when the output node is dirty. So let me jump back down. And we want to say that if any of these attributes change, output needs to be recomputed and set to dirty. And then finally, we just have our boilerplate code like you remember in the simple commands. We just initialize the plugin. Here's my name. It's version 1.0, and as I version it up, I can keep saying 2, 3, so that it shows up in the plugin manager. And then we just register it like normal. So again, this is just boilerplate code. And if you see right here, we're using the node ID. And this is that part where it registers it with that node number. All right, so now that we've got the whole setup laid out here, we can go back and talk more about the compute method. All right, so like I said, we only care about computing the output because everything else is driven by either the user setting the input or by that time. So after we get all of our data, and right here, like I said, we get back an mTime from the time attribute, and mTime has a method called asUnits. And asUnits takes a constant of what kind of unit you want back. So mTime has a constant called seconds. So this says, give me back the value of mTime as seconds. It has other attributes, like if you just want to get it in minutes or some other unit of time. But we care about seconds in our case. So now what I'm going to do here is we need to generate new x, y, z points. And I'm calling another method that we have down below called getShake. And getShake is going to take the current seconds value, and it's going to take the frequency x. So you can see here we take, because we have a 3 float, frequency and amp are 3 floats. They're an array. So I can get the x, the y, and the z. Same with the amp, x, y, z. Then we give it our seed that was brought in, and then we pass it the amount of octaves. And now you see what I'm doing here is I'm modifying the seed by a constant amount each time. That's where we get our randomization. As you remember in the, I should really leave this open instead of constantly bringing it up again. As you remember, we have randomization between the three. They don't line up over each other. And this is where we get that functionality, is by adding an arbitrary amount. This could be anything really. It could have been 100. I just chose 250 and 500. If we had not done this and just passed in seed each time, then it would be the exact same, unless, of course, the frequency and the amps were different. But if the frequency and the amps were all the same, as in, let's see here, select this again. If, in this case, where they all are the same, then it would lay right over each other and be the exact same curve. So that's why we randomize these seeds. But again, you would get constant, because the seed itself all comes from the same seed number. This is reproducible. Okay, so once we get our new XYZ values, we need to set, just like we got the input value here, we use our data block to set the output value. We pass in our handle to the output node that was defined up in the class attributes, and we are given back a handle. Now, this gives us just a handle, just like these are just a handle to the input value, although we did cast this right here, so then you get the value. If I had taken this off, like that, then you'd get a handle to it. But we just wanted the value. So down here, we get a handle, and then we set the float 3, x, y, and z. And this needs to match up with the right type. If you tried to set it to something else, you might get an error. You might be able to set it to 2, I'm not really sure, and just pass x, y. But just to be safe, let's make sure it's set float 3. And then the final thing we do on the data block, we set this plug to clean. So if we were able to generate a new value, then we have to make sure to set it clean. And that means that this doesn't have to be computed again until something affects that output node and makes it dirty. Now, say we were in here and we were trying to figure some stuff out and we didn't like the current state of data, we could leave it dirty, meaning that it needs to be reevaluated again next time. But this is where you say, okay, I've given it the right values and I set it to clean. And the last thing we do is we return a constant success from OpenMaya. mStatus contains all the status signals for any kind of error. So one of the constants is success. And then what you need to do is if it's not going to check the node, the plug that you want, the default return value needs to be unknown parameter, meaning that there was nothing needing, this plug didn't need to be computed. So if some other output or input attribute came in here and it wasn't one you were operating on and you didn't set it to clean, you should default return unknown parameter. So now's the point where we actually get into what getShake does. And to generate our shake value, before I explain what getShake is let's look up at the top of our node, and you see that I imported this pnoise. And pnoise is Perlin noise. If I open up this Python directory, and the reason that we're able to, well, let me get into that in a second, but let's open the pnoise. And actually, I'll explain. The reason we can actually import it like this is because if you remember, we set our Python path to plugins Python. Now, generally, like I said, you could set this to a facility location or a common location, but for our project, we added this to our Python path, which makes everything in this directory available for direct import. So we import pnoise, and what this is the algorithm designed by Ken Perlin, and this is the actual source of his. He wrote it. His example is in Java, and I took this from this website here, where someone rewrote this in Python, and I just made a couple small tweaks to it. But what he does here is, and you don't have to get into how this works because basically I don't understand it. It's beyond my level of math. But he just starts with this huge table of pre-generated values, and he has these various functions that end up creating what you saw as that noise. It just does a bunch of math, and given the input values, it'll give you back a randomized number. So all we're going to do, again, you don't have to understand how this works because I barely understand it myself. All you have to know is that we are importing it and going to make use of it. So if I come down here to the get shake, this is where we actually generate our random numbers. And as you can see from when I called get shake, it takes a float time, it takes a float frequency, a float amp value, a seed, which we say is a default 0, so if you didn't specify the seed, it'd be 0, and octaves, which is default 3, and it's going to give you back float noise value. All right, so let's look down here and see what we do. So what we do is, we just do a catch, like if they passed in 0 amp, 0 frequency, just return 0 because there's nothing we can really generate. They need to pass in some sort of amp and frequency value. And then we go down here, and we're going to loop over our octaves. And what this does is, if you do range 3, that's going to loop over 1, 2, and 3. And you see I'm using this special syntax again because we actually don't care about the number, the octave number. We just want to loop 3 times, or for whatever amount of octaves they pass in. And what this is this is a fractal sum. And what this does, and again, Ken Perlin defines how to do this on the website at the top of this file. But what we're going to do is every time we loop in an octave, we're going to generate noise. And we're going to do it multiple times, but every time we loop, we're going to increase the frequency we're going to double the frequency, and we're going to have the amplitude. And then we're going to add the results to the value. So let me show you what that does. Okay, so as I said, you have this really fine functionality here. So if I were to do it again, let's see here, let me create a new scene, move this down, and let's create a new sphere here. Okay, let's set the octaves to something crazy like 8. Okay, and let's bake those results. I'm just going to bake it to like 300 so we can go quicker. And let's just so you can see some differences. Let's make the Y bigger in amplitude, and then let's create the frequency. Let's say this only has half the frequency, and this has double. So you can really see the difference in this. And let's bake that. Oops. Let's actually hit enter and not the period key. So we're baking that. And let's take a look at our results. So look at X. We said X was an amplitude of 1, a frequency of 1, and this is 8 octaves. And what you can see here is this fine jitter. Now we don't have as many points here, so there's a certain limit to where it doesn't make sense anymore to add more octaves. We could set a max on that. I'm not really sure what that is because I haven't tested, but because we only have so many points, and it also depends on your actual amplitude and whatnot, if your amplitude is really big. But you can see that there's a lot more micro variation on here. So that's how you get that really fine jitter. And if we look at Y, and let's look at these two over each other, you can see that Y amplitude is a lot greater, or I'm sorry, yeah, Y is a lot greater and half the frequency. So you can see the frequency is a lot less, but you get these micro jitters here. And then Z had more frequency and less amplitude. So you can see how Z is actually the smallest. So that's how we get our variation, and that's what the octaves is. It's the repeating it and getting those smaller variations. If you set it lower and lower, you'd have a much more consistent curve. Let's open this back up here. So that's what we do. We loop for every range. We generate, we call P noise, and P noise takes a value. And this is what we do here is and this is similar to when you're doing a sine curve to create, a curve like this. We send the time plus the seed times the frequency. So as the frequency is increased, the difference between these numbers, because time is going to be linear, because it goes 1, 2, 3, 4, 5 in the seconds. The seed is also constant, so pretty much this whole thing is just a linear rising number. And then we use a frequency to make the jump even bigger, which is what gives us those bigger differences. And then we take the result of p noise and we multiply it by the amplitude, which basically is what controls, actually this controls the frequency, and then this controls the amplitude. And that is what our value is, and we keep adding it. And that's how you do the fractal sum like that. So that's pretty much what getShake does. So you see that we send these values in, we get our new x, y, z, we set it out, and then we get our node. And close this here. Now, the way you get this really nice looking attribute editor output is, let me explain the companion files that go with creating a node. When you create a node, there are two more types of files that you can make. One is for the attribute editor, this AE shake node template mel. Now what that is it's actually a special naming. When you make a node, you have to create this mel script that's AE with a capitalization, the name of the node, and the name of our node is right here. And it needs to match up with the actual node. So what is in that, let's see here. Okay, what's in that is some basic mel, and again, you can pretty much copy paste this, but this just basically tells the attribute editor how to lay out your options differently. If you didn't have it, there's a default that has some extra stuff on there that you may not want, like the caching setting and stuff like that. You don't have to write this, but if you, and actually I can show you what that looks like. Let me go ahead and okay, I'm going to comment out that here. So now we're not going to load. Let's close down Maya. And let's open up Maya again. All right. And let's load our plugin. I should have left it to auto load, but here we go. So let's load that. Let's create it. Now you see the difference. We don't have the nice fancy twirl down. We have all these default node values. So this could be perfectly fine. If we don't want to see these things though, then and we want to add our own sort of ways of representing these numbers, that's why we create the template. And what Maya will do is when it goes to create that node, it will look for, and actually I name this capital S. That doesn't really matter. It's actually the name of the proc. So it needs to match. See how it's a lowercase shake node, and I've got my name is shake node like that. So it will look for a matching template that's shake node template, takes the name of the node, and this is how it creates the template. And the other thing that we create to companion our node is this shake node command script, because there are some ways that this has to be set up, and I haven't explained where the time value comes from yet. You've only kind of seen it. But we create this convenience function, and what it does is it first checks if the plugin is loaded using commands plugin info. It asks if the shake node is loaded. If it's not, we generate an error. And then it creates the shake node for us, and then it connects. Now time 1 is a node that's always there, and its attribute out time is always spitting out the current time. So we connect time 1 out time to our shake node's time attribute that you saw that we set up right here. And actually more specifically where we set up right here. I could have said current time or time. And the last part of the command is we say that if the command if we passed in a transform node right here, then and it exists, well, we test if it doesn't exist, then it raises an error. But if it does exist, we help out by connecting the output of the shake node to the translate attribute on the incoming transform node, and then we return the shake node. So let's see what that actually looks like. All right, let's make this a little smaller. All right. So what we do is open a new shell here, and I'm going to do import shake node command. So now we've got our shake node command, and let's get the function. So we want to call create shake node. And this is the first way that we can run it. We can say, let's actually make this easier. Let's say from import shake node. All right, now we've got this command, and we can just call it, and I'm going to say shake equals. So if I run it, now we get a new shake node. I can run this a couple times, and you can see new shake nodes. And so this is a convenience function that's already connected up to the time node, and we can actually test that out. Let's create just a random shape, right? And let's pass in the transform. So if you see, it's actually connected. So that's how this convenience function works. It's a lot easier than having to have this this whole set right here. So the idea is, again, to recap, you create your node, and then you create a companion set of functions that make it really easy to use it. And that's pretty much all there is to creating a basic node. And just to recap some more, you know, the example here of using this pnoise module is just a way of showing how you can, because of Python, you can go and grab existing libraries anywhere, you know, free off the internet, or, you know, shared resources that you've created before, and bring them into your definition of creating a node. And we've created this little hierarchy, and you know, it's a complete plugin. So that's it for this chapter on looking at the API. Okay, so this is a bonus chapter on how to install PyQt for Maya, and the benefits of that is, as we said before when we were doing the Qt Designer demo, is that there is actually a library where you can use Python completely to design your UI, and you get a lot more power, a lot more flexibility. But the reason that this is a bonus chapter is because it's a little more technically involved to install PyQt into Maya, because you have to build it. And so it takes a little bit more knowledge. But since the last chapter where I was talking about Qt, I was thinking, and I wanted to correct something that I had said when we were downloading the Qt version, and I said get 471 because you could build off of that later. You can't actually build off that, but it's good to have the right version to that matches what Maya is using. But I also was looking at an easier way to give you PyQt. And number one, if you're a Windows user, what you can do is, if you search for PyQt Maya 2012 precompiled, this first link you get, you can actually find people have built PyQt. You just, for Windows, this is really great because you can just download and install this. And so that sets you up for Windows. But I couldn't find anything like that for Mac. So what I did was I actually built an installer that I plan to include. I'll either include it in an installs directory like this if you're a Mac user, or at the very least I will include a links to where you can download this. And if you're a Linux user, I don't have a build for you, and I'm not sure if one is precompiled, but I assume if you're using Linux, you're somewhat savvy enough. And if you go to my blog, and I'll include a link to this as well at justinfx.com, I wrote up an instruction set on how to build PyQt for Maya. This was written for 2011, but since then I had updated it for 2012 with some just new versions. The instructions are the same, but with some new versions. But I will try to include this document with the tutorial, so that if you are comfortable compiling on a command line, you can actually build this yourself. But for Mac, I tried to actually put together something where it was pre-built, and there's one for Windows. So let's take a look at the difference. If we bring up our code, and I'll actually show you where it is here. It's in the PyQt directory under the asset importer. And before we had the Qt with the asset importer window and this UI file that we loaded directly into the code. But what we do now, if we look at the PyQt directory, let's move this over, is you see that in addition to having this asset importer window, I've moved the rest of the code into this UI subdirectory. It's a package, and we have the UI file, but we also have a Python version of the UI file. And I'll explain how you do that, but let's take a look at the asset browser for a moment. And let's open up the script editor and make sure our code is on the path as usual. And we're going to do a little bit of a longer import statement. We're going to say from asset importer PyQt, which is our package level directories, import asset importer win, which is our PyQt version of this module, as asset PyQt. That would avoid any name clashes if you were importing before. We're just going to give it a different name when it comes in. So we're going to run that. And then we're going to run the show command. And as you can see, it looks very similar, but I've done a few extra changes. I have added a show drop-down, and I've also used a splitter, which is something that I could do in PyQt really easily, to split the windows like this. You get a lot more control, and I use these group containers, as you can see with the titles. And now it was much easier to lay this out and have control over it. So I can just refresh the library, and I see everything. And if I use the show drop-down, when I switch that, I get a filtering. So now you can see how you can actually add filtering, and this is with when you change this, it fires a signal that hits a change routine, and it shows all of them, and it works just as expected. There you go. So, and you can see this is a different title, PyQt. So let's go ahead and close this, and let's take a look at what's different in the code. Okay, so I was talking about how I moved everything into this UI directory. And instead of using this UI file, and actually I'm going to open that up and open recent, and let's make this a little smaller. Now everything is still pretty much the same except for, adding the splitter and adding this drop down and giving that a name called show box and putting these in groups. So I saved this file just like normal. But instead of using it directly, what we do is we can convert it into a Python module. And it looks like this, and you don't even have to mess with any of this. This is the entire layout in Python, but it's auto-generated for us. And the way I did that is if I bring up a shell, and again, this is somewhat unique to maybe your system if you're on Windows or Mac or Linux, but the common command that comes with installing PyQt is pyuic4. Now, because it's installed into Maya, it's a little bit more difficult to get to. You have to have it on your path. If you're using my OS X installer, I've created a convenience one called myuic. And the way that works is it just takes where you want to save it to. And let me bring up my Finder. So I can say that I want to save it to, that's my output file, and then I have to give it my input file. And if I hit enter, it makes me this Python, which wouldn't have existed before, but now it's created. And if we go back to the code here, we don't need this. And let's open up our asset importer. Let's take a look what's different. So I'm using a slightly modified asset importer 4, which is the 4th version. The last time in the Qt module we were using the 3, and I'll take a look at this in a second. And now what's different is I'm importing two PyQt modules from PyQt, which now exists because it's installed in Maya, Qt Core and PyQt, Qt GUI. These are two things that are pretty common to use. And then from my UI package that I moved everything into, I'm importing asset importer UI, and this is actually inside, that's a class that's inside here. And then I have this flow layout that I'm importing. And this is another example of how you can grab stuff off the internet. This was actually included in the PyQt examples. So I just grabbed this out of the examples and included it here. It's a different type of layout. We were using a grid layout before, and now I have this flow layout, which is going to do a lot more nice work for me, and I'll show you what that does momentarily. And then we have these two utility functions, and this is kind of a little helper tool when you're using PyQt. So I import from the API this, it's a UI helper, and then we need this module called SIP, which also comes with the PyQt installation. And I'll explain that in a moment as well. Then what I do is, when you create a PyQt application, you can only have one in an application, and because an application exists in the Qt of Maya itself, what we do is we set this global and we just grab the instance. So if you had 5 of these different types of PyQt scripts, you would always just use the same instance. You don't want to create a new one. Normally in PyQt you would create a new application, but this is how we just share this global reference amongst the various applications that we install. And so let's go through this part of the code. Here's our same class, asset importer win, but now we're inheriting from two things. We're doing multiple inheritance. Number one, we're saying that this is a QDialog, which is the basic type of dialog in Qt. And then we're also inheriting from our UI file. And this would be as opposed to loading it in manually from the file. And then we have our init, and we call the superclass init just like we have done before. This is not changed. None of this has changed. Now here is something new. When you inherit from the UI file that you created, you get this setup UI, and all you have to do is call setup UI, and it completely sets up with all the widgets that were created. And from that point, I have access to all the widgets. Here's where I have access to the splitter that I created, and I have access to that because if I open up Qt, and you see I created a splitter called splitter, and it comes in as splitter. I just have access to it like an object, much better than having to access it with Maya's UI commands. Here's how we create the library layout, and if you remember before, it was a grid layout, but now we're using that flow layout that we imported, and we're saying it's parented to the scroll window. And the cool thing about the flow layout, if I bring up the script editor again, and let's bring this up and refresh. Now watch what happens to the layout of these icons as I make the window smaller. They automatically reflow. That's not something you get with the Maya layout as far as I'm aware of with the grid layout. You have to specify how many columns, but this flow layout automatically recalculates the row column configuration, which is really great. So that's another cool thing about PyQt. And then we go down here and we created our show box, which was the combo box, and all I do is I clear it. I add that blank item, if you remember first. I should really leave this up so we can keep referencing it. Yeah, I'll leave it up. So you see how there's a blank one first. That means show all. So we add that first, and then we list shows, and this is something that we added to the new importer when I said I made a version 4. We say for show in the importer list shows, and we add each show to the show box. And if I open up asset importer 4 and I look down here, I have a new method that I wrote called list shows, and all this does is go into the root directory of the asset location, and it finds each show path, and it adds it to a list of shows, and then it returns it. So this basically just gives me a list of all the shows under my asset root location. So that's how we generate the list for the box. Now this is a new concept in PyQt. In the Qt we used commands, and we had to edit the button and say command equals a reference. Now the way you do it in PyQt is you have these things called signals and slots. Every widget has signals that it emits under certain actions, and buttons have a clicked signal. So what you do is you say from this reload button clicked, connect it to refresh assets, which for the most part has not changed, just one or two things. Same with the other button connected to refresh imported. The imported list has an item clicked, which is very similar to the other import list that we had. And now we have this show box, which has a every time a current index in the box has changed, connected to this new one called refresh assets, which actually is the same thing but with some more arguments. So now we have refresh assets, and the only couple things different in here is the different way we clear out the library, which is this right here, how this gets cleared every time this needs to refresh. And the way we clear that is we just say while it's not empty, we loop over the library and we take out the first index and we destroy it. That clears out the box. And then we get the current show that's set in the show box. And if it's set to something, then we set our importer. You remember how we can set the importer show so that it's working on that show. And we set all shows to false. Otherwise, all shows is true. That's how we get, that would be all shows in the importer. That would be the general show, and then the war show. And now down here, we just loop over the importer list. This is exactly the same as the last Qt example in Asset Importer 3. We just say all shows equals whether it's true or false. So this would either give us all shows or the current set show. Same idea here. We create a callback using the partial, and we say load asset, and we set. Now this is kind of a new item here. These are no longer icon text items from Maya. These are a widget that we've created. And what I'm saying is I'm going to get the asset and I'm going to create this new type of widget. And I'll show you what that is. But we create this widget. We set the text for the widget to be the name in the show. This is similar to the last one as well. And then we create a connection on the fly. Each one of these items has a button that can have the clicked connect command. So every time one of these is clicked, it fires off this command, which is set right here, which means load that asset. And then we just add the widget to the library layout. Let me jump down here because we're talking about it and show you this asset item. What I did here is I created a new kind of Q widget. And a Q widget is pretty much any visual object you see in the visual interface. So I create a new asset item. I give it all these defaults, like it needs the text, the image path, and then I set up. This is how I'm manually creating a widget without the Qt designer. I give it a vertical layout. I add a push button and a label, and then I add them to the layout. That's how you see this push button label in a vertical layout. And then I say if the text was passed in, set the text. If the image path was set in, set the image path. If there's a size, set the size. Otherwise, there's the default icon size. And I just have these convenience methods of how to set the text, how to set the image path. And to set the image path, the button has a set icon method. This is a button with a set icon method. Oops, let me go back here. And you have to basically take the path and convert it into what's called a Q icon, and then you set the icon. And here's how you set the fixed size for the button. So each one of these items represents one of those buttons. And if we jump back up here, you see that I create a new widget and add the widget. So down here under refresh imported, this is very similar as well to the rest, except we just have a way to clear the list really fast. And we just loop over find imported. And now we have what's called a Q list widget item. So instead of just adding text to the list like in the Maya UI, you have to actually create these items which actually hold more information. It's really nice because you can store more stuff, which each one of those besides just text. So I create a new one of these items. I set the text to be the name of the widget, or of the imported path, actually, my mistake, the imported path. And then I set, now this is an example of how you can set a new attribute on the fly. This doesn't have an asset attribute, but it gives me the flexibility to just say dot asset equals the actual asset object that we created. So it keeps a reference to this asset item. It's really cool because when I go to get one of these back, I already have the asset item. I don't have to look anything up. And then I add that asset item to the list. So basically, every time I click on one of these, it returns me that list item, and I can just directly access the asset that's associated with it. And then this is the import item selected, which is the same from last time, except a couple small things. The item that comes in, we get the text of the item, which is in this case, a QListWidget item. So when that fires, instead of sending us the text, it sends us the list widget item that we set up. We grab the text out of it. If it exists in the scene, we select it. So this part is not different. And now this is the toHelper. You remember this is the helper function for showing. And these are slightly different. I'll show you why. Now, you create the instance to the window, but you have to say the parent equals this getMyaWindow function. Before it was simply just like that. But because this is a PyQt widget, we want to make sure that this window is parented to the Maya window. And you can see that it's on top and it comes up centered. If you don't parent it to the Maya window, it comes up anywhere off the screen and not parented to this master window. It doesn't see any kind of association between them. So you use this, my mistake here. We have this little convenience, which is also kind of a canned thing that you can keep reusing, where what it does is it uses the Python API, the MyPython API, to get the main window reference, and then it uses the SIP module to wrap it into something that's an actual PyQt object. So that way we can just say getMyaWindow, this is an actual PyQt object, and then we show it. So that's the difference in those, and you can see that it's a lot cleaner to create it in Designer, convert it, and have access to all these. As you notice, I didn't have to use the delete me button to do any kind of workarounds because we have object-oriented access to the splitter and creating a flow layout and the box. We don't have to find anything inside of Maya, and these signal slots are very powerful in just connecting all the various signals that get fired from these widgets to a handler. And that's pretty much it for PyQt. I apologize if this is kind of brief because I can't cover everyone's specific setup, but I want to hopefully make this as easy as possible to install. So look for the links in the package directory. I'm going to try and include a links of where you can, if you're on OS X or Windows, where you can download those. If you're on Linux, you can follow the instructions and hopefully get this PyQt set up for you. Alright, this concludes the second volume of the Python for Maya video. I know this was a lot of information, and my goal was to give you a ton of information in this video, and with the hopes that at any point you could go back and pause and look it over, and also that I've included a lot of documentation, notes, comments with all of these files that we talked about, so you can pause and read and see what's going on. So I just felt that it's better to give you more, and you can look at what I've given you and take a look for the links that I will include with the project. And again, if you ever have any comments or questions, feel free to email me, which will also be included. Thanks a lot.